Hi class, good afternoon everyone. This is Rakesh Talreja once again back to the Target Gate 21 batch with the fresh subject, with the technical fresh subject that is the control system. So how are you all my dear students? We had studied mathematics earlier. Maybe some of you are new to the Target batch number 2. Okay, Target batch number 2. But yes, I am fine. Yes, Aruna, Yashwant, I am all good. Very good afternoon, everyone. So, we had studied about engineering mathematics, the subject just before analog circuits. Okay, and the target two students who have joined in the target two students, I'll come up for the mathematics in the later half. Fine. Yes, yes, Meera, I'm fine. Yes, Akash, I'm all good. I'm all good. Yes, Pushkar, I'm fine. Hope all my dear students are fine. It's the beginning of a technical subject that is the control system. And today, the first class, we have two classes today. Today we have two classes, and that is the introduction to control systems and sensitivity. I'm fine, Rahul. Hope you are all fine. Okay. Okay, so you watched my class on the live at IIC. Yeah, that should be seen because you get motivation, you get little motivation. That is, IIC is like one of the biggest reason to get your preparation on track for the gate examination. Fine. So, today's first class will be on introduction to the control systems and a small topic known as sensitivity. Okay. And that's on YouTube. That's on YouTube. Wait, I'll share the link. Meanwhile, when I give you some questions and all there, I'll share you the link. You can watch it anytime. I took that session last Sunday actually. Okay. Right. So hope you have enjoyed studying the analog circuits. Before that, we studied mathematics, and you were enjoying that. Hope you have learned quite a good amount of analog electronics by by the very good faculty Ramesh sir. Okay, Vicky, your first class of grade up. So welcome to the grade up, and you'll be enjoying your from the first class to the last class. That's the assurance from the grade up team, right? Okay, Nandish, you also purchased this course. Yes, very good. You have purchased the course today. No problem. It's a beginning of the fresh subject, so that's a fresh class for you. Okay. Actually, so the second class today will be on the block diagram. I hope you are following the study plan. And the second class will start with the block diagram reductions. I'm fine. I'm totally fine, Ram Prasad. Okay, and the first class, let's basically understand some important elements of the control system, basic introduction about that. What is the concept of sensitivity? Few basic things we'll take on this session, and later on we'll start going to the block diagram reduction. Right? Hi, Sarath. Okay, so yes, I see everyone in good energy. Yes, I see everyone in the good energy. So let's get started with the class with that same good energy. Okay, no problem, Yashwint. It'll be fine. It'll be fine. Okay. Yes, Saurabh Kumar, when did you join? No prior knowledge. See, my class, no prior knowledge. Whatever is there, I'm going to tell you. I am going to tell you. Okay, Akash, you have watched it in your recorded class. Yes, it is available in the recorded class. No problem. No worry if you have not learned about control system. I am going to tell you what to do, what not to do, and what are the subjects to be taken, and etc. Okay. Yeah, Saurabh Kumar, if you have joined on May 12th, around that, I think mathematics was finished. It will be again conducted for the target batch 2 students. It was done for the target batch 1 students. It will again be conducted. It will again be conducted later on. Don't worry about that. It will be there for you, Saurabh Kumar, but later on, it will come up. Once you have joined any batch, that means it is the responsibility of the grade team to complete the whole syllabus. Maybe the subject's order will change. Yes. No problem if you're a batch 2 student. Mathematics will be done. Mathematics will be done. Right. Chaliye. So this is first of all the brief introduction. Me already batch 1 are well aware with me. Batch 2 students, I'll just tell you a brief introduction about myself. Okay. Okay, so you are also going through some lectures, Karthik Sai. Okay. Okay, so Nandish, you are motivated with respect to IIC. That's good. That is good. Okay, good afternoon, Zion. So basically, guys, I'm Rakesh Talreja and I've secured All India Rank 9th in the GATE examination, and I've completed my Masters from Indian Institute of Science, Bangalore. And that's why last Sunday on the Grade Up Gate YouTube channel, this video is available on the Grade Up Gate YouTube channel. I took a session on how the life at IISc, what were my experiences, with respect to studies, with respect to laboratories, with respect to the general life as well, because you have to spend your life in the hostel. So how you feel, A to Z, I just try to speak about that in that session. My major area of expertise, okay, my major area of my BTech is basically, my BTech is from electronics and communication engineering. My BTech is from electronics and communication engineering. My major area of expertise is engineering, mathematics, and quant, which is common for all. Apart from that, control systems is what going on right now. And I do take electromagnetic theory. I have taken some CFT classes recently on the Grade Up app. I take signals and systems and digital electronics. Okay, it's been more than 10 years for me in this industry for GATE and engineering services examination, teaching students for engineering services, GATE and various public sector examinations, and mentored more than 20k plus students till date. Okay. So dear students, before I start off any topic, let me give you an overall hint, because you're starting a course. So what's that course all about? What all you're going to see? Let's get started with the syllabus. I'll give you the introduction to the subject, whole subject. If I talk about the weightage, of this, see, if you are, obviously target batch is dedicatedly batch for the GATE students. If we talk about the GATE, on an average for the past 10 years, if I take, because why past 10 years? Because from 2010 only this 100 marks, 2009, sorry. This 100 marks pattern has come up, and on an average, whether you are an EC or electrical student, the control system in GATE approximately carries the weightage. What is your expectation? I'm not giving you the exact average, because obviously some deviations will be there every year, but what is the most likely expectation that you can expect from this subject is 9 to 11 marks in GATE. Whether, this is the expectation, this is the expected marks, I say. This is the expectation that you should keep from this subject. Expect 9 to 11 marks, somewhere around 9 to 11 marks. Okay. Most likely this is the expectation. Now sometimes it may be 8 marks, sometimes it may also go to 12 or 13 marks, but most likely 9 to 11 marks. So that's a decent weightage, and that's a decent weightage. Whole subject is more or less a combination of mathematics and graphical techniques. Okay, so mathematics and graphs combined together make the subjects whole interesting. So many of graphs coming up from the root locus, Nyquist plots, Bode plots, etc. So it's a very graphical and very interesting subject. I'm going to study it in a very interesting manner. Few, first beginning lectures are very simple. The main part is the stability analysis, from which good questions, conceptual questions keep coming. Okay, but yeah, the basics is important to go forward. Questions from the first few lectures are very simple, but questions from stability, when you say they are in good in nature, there you need to practice a lot. So it's really an interesting subject. Even if even this is Anupama, please, you can refresh yourself. You can refresh yourself my video, because I'm also, while teaching, I'm also watching my video in a parallel laptop. Okay. Yeah, Yashwant, let me complete the syllabus part, and I'll tell you that. Yeah. With respect to ESE also, if you want to know, although this is the GATE batch, but I'll give you the hint about ESE. With respect to engineering services, in the prelims paper, it is nearly a business of 12 to 15 questions. Approximately 12 to 15 questions, and that means how much? That means every question in engineering services prelims current pattern is a 2-mark question. So approximately like 24 to 30 marks in the prelims you can expect from this subject if you are preparing for the engineering services prelims also. So that's also a good weightage, and the nearly 10% you can say, because the technical prelims paper, the paper 2 of the prelims is 300 marks, right? Okay. No, Likhita and even Anupama, can you please refresh, because I am able to watch? Yes, everyone other is able to watch my video or not? Watch me. Everyone is able to watch me, listen, hear me carefully. Yeah, that's what. Maybe just reopen, close, refresh once. It should work fine, because it's running in my screen, the other screen. Right. Okay. So, yes. And even many of the names also I'm able to recall. Okay. Many of the names also I'm able to recall from the mathematics class. Apart from that, if you talk about engineering services mains examination, this subject approximately carries in the paper 2, it's included in the paper 2, and this carries approximately 70 to 80 marks within the paper 2. within the paper 2. The paper 2 weightage is 300 marks, and out of the 300, it is around 70 to 80 marks for this particular subject only. So for all the things, for all the papers, whether it is engineering services prelims or mains or the gate, which are focusing right now, okay, is it's an interesting subject. It's a scoring subject. It's it can be made scoring if you learn with all the concepts. So I'm going to deal with all the concepts, all the questions, all variety of questions. Need not worry. All variety of theorems, all variety of derivations, everything is going to come up here. So need not worry about anything with respect to my class. Okay, so Srinivas has enrolled just right now. So welcome to the Grade Up Target Gate 21 batch. Yeah, students. So this is what I'm trying to highlight, some of the syllabus parts. I'll move through the syllabus once. Yes, I'll move through the syllabus once. Chaliye. So today's class, as you know, introduction to control system and sensitivity. This is what is going to be discussed in this class. We have next class at 5 p.m. where we talk about the block diagram. So in introduction, I'll just basically introduce you what do you know about, what do you think about control systems? What is the basic differences between open loop and closed loop control systems? Which is more important in which area? Okay. What is the concept of sensitivity? Hi, Sai Kiran. What is the concept of sensitivity? Why do we study sensitivity? And then we go towards the representation of control systems through block diagrams and signal flow graphs. Okay, so today's next class, that is at 5 p.m. Today's next class, that is at 5 p.m. we talk about the block diagram reduction techniques, the various rules to be applied on block diagrams. Okay, even block diagrams can be converted to signal flow graphs and then solved. But why I take it a separate class on block diagrams? Because there are some questions which are relatively simple. Unnecessary, students mostly focus only on signal flow graph, and directly, there are some questions which are very simple with respect to block diagram and unnecessary, need not convert into signal flow graph. If a graph is given, then you can directly apply the Mason's formula. Directly, if a graphical question is given, you can apply the Mason's gain formula. But suppose if the question is on block diagram, first you will convert into graph and then apply the Mason's formula, it becomes lengthy. So some questions are easily solvable by block diagram. But yeah, most of the questions are simplified by signal flow graph. But some basic conceptual questions that they target in the gate examination, for that you need not convert into signal flow graph. That will be a waste of time for you. So I want to show you that question. So we have a dedicated class on the block diagram reduction, and then on the next class, that is going to be on Tuesday, because Monday is off for the target batch. So next class Tuesday, that is the signal flow graphs, we are going to begin with. Okay, so we have around one and more than one class for the signal flow graphs. Around approximately 1.5 to 2 classes I'll be taking for signal flow graph. How to reduce the graphs using the Mason's gain formula. Vast variety of questions can come with respect to no, don't worry, Abhiram. Don't worry, Abhiram. Don't have a minimum knowledge. Don't worry. I'll tell you my proceedings. That's why I'm giving you the syllabus also here. So signal flow graph, non-touching loop pairs and loop triplets, what are path factors? So variety of questions can be found there as well. And after studying this, we go towards the next, that is the time response analysis. The next chapter, that is the time response analysis, after finishing this basic pass. Now, even the questions, I'll tell you, from the time response, okay, time response analysis are easy. Questions are relatively easy. With respect to questions, if I say the questions are easy, but this topic is going to set the whole concept with respect to the time response analysis. What is the behavior of control system? How do you define stability? First you define stability. Okay, then you understand, and then you explore more about stability in the upcoming topics. So we study about the transient and steady state. What is transient? The initial part of the response. Steady state matlab the response of the system when t tends to infinity. Okay, so what is the initial behavior of the system and what is the final behavior of the system with respect to time? So you have applied some input to the system, and how does the system behave with respect to time? Everything in this chapter we talk about the behavior of the system with respect to time, and the behavior itself talks about the application, the practical application of system. From the behavior we take, yeah, this system is practically useful, this is not behaving as I want, so this is not practically useful. So it's important to decide which systems are practically useful or not. There also we define. Within this only I will come up with the definitions of stability. Okay, we have a separate discussion on steady state error. An important question in GATE comes up from steady state error almost every time. Okay, and then what is the concept of dominant pole, and with the dominant pole, how can you study higher order systems? By approximating the higher order systems into lower order systems by using the dominant pole concept. Okay, so this chapter for concept, it is very important. Now all the concepts will start building from here. Okay, all the concepts of the control system will be start building from here. That is the time response analysis. First order is a very basic simple portion, but most important is the second order control system analysis. This is important. Okay, this is important, and obviously these two are pretty much important, right? And then once learning the concept, what is the behavior, what is the stability of system, we are going to move into the topic of stability. We are going to move into the topic of the stability. Okay, and stability mein first of all I define ki yeah, what actually is absolute stability, what actually is relative stability. Absolute stability basically means that you are judging the stability of the system in the form of yes or no. Okay, in the form of yes or no, that is just the quality of the system. Absolute stability methods are known as qualitative methods, which they specify the quality of the system, whether the system is stable or not, just yes or no on that. But when I talk about the relative stability, I'm going to give you the definitions once I start that chapter. I'm just giving you an introduction of the subject right now. Okay, and once I talk about the relative stability measures, relative stability may not only quality though will be known ki stable versus unstable, but quantity of the system is also known. Quantity matlab, suppose two systems are stable, both are stable, but which of them is more stable? To compare, to have a relative analysis of the systems. Okay. Likita, maybe log out and log in, because I've just taken the feedback from others also and I'm watching it, so I think it's working fine. Just try to log out, log in once, or immediately contact the GradeUp team. Maybe some issue from the app end. Okay, just even immediately try to first, I think, refresh or log out, log in. That would be fine because everyone is able to see. Close the app, reopen the app, or if you are watching in the laptop, just log out and log in once again. Okay. No, Nandish, all videos of this course are not available on the YouTube. Okay. Okay. So in relative stability, we talk about the quantity of the system, and quantity being defined in the form of gain margins and the phase margins of the control system. Okay, so the system which is more stable will have more gain margin or more phase margin. Accordingly, we classify the weight of the quantity. If two systems are stable, which of them is more stable, right? And then first of all, in the stability, we start with the absolute stability analysis. Okay, an absolute stability analysis, the method that you learn is the Routh-Hurwitz criterion. This is important for questions. Okay. This is important for the questions. Variety of questions come up from the Routh-Hurwitz criterion. So we'll take all possible cases once we go towards the Routh-Hurwitz analysis. Okay, and after moving towards the Routh-Hurwitz analysis, we take up the next techniques where also we talk about in the root locus, we also determine the stability of the system, and root locus is also helpful for understanding the time response of a system. Some transient parameters like damping ratios and all can be extracted with the root locus for higher order system. When I say time response analysis, as I have seen in the syllabus slide, it is analytical methods, mathematical methods are valid up to second order system. Higher order system पे भी valid है, but higher order system पे it is little complicated solving it analytically. तो हम क्या करते हैं higher order system में? हम क्या करते हैं higher order system में? We go towards the graphical techniques, and one of them is the root locus. If you want to do even if you want to get the time behavior of the system or A to Z about stability की, when the system is stable, because stability के लिए we have now three regions. The system may be stable, the system may be unstable, or the system may be marginally stable. ठीक है? The condition of this depends on the poles of the control system. How on the poles of control system? That is what you are going to learn all about. That is what you are going to learn all about. So poles of the control system, and root locus is going to give you the complete information about the poles of the control system when the system gain K is varied. And in the root locus itself, we have, first the root locus, then we have the complementary root locus. Root locus for K greater than equal to 0, complementary root locus for K less than equal to 0, and root contours is a different case when something other than K is varied. Okay, so I'll explain you, I'll give you the definition of root contours that time. And after studying the root locus, we go towards the frequency domain analysis, and thereaway with the frequency domain analysis, I start the relative stability measured. I told the relative stability. Okay, the quantity to measure the methods to measure the quantity of the system. Right. I hope your dear students are following the syllabus. The coverage is important. It's just not like starting any topic, but I want you to know what all you are going to study, what the subject is all about. Right. So frequency domain analysis mein first of all we study some concepts like what resonance is, what is the resonance peak, resonance frequency, what is the concept of resonance, why it is important to discuss resonance here, and then we go towards one of the very important topics of the control system, that is the Nyquist plots. All these three topics are very important. Every year minimum 1 to 2 questions in GATE are definitely expected, sometimes from Nyquist, sometimes from Bode, or sometimes from gain phase margin individual question, or sometimes maybe from two of the topics. Suppose there may be a question from Nyquist and Bode both in the same year. Okay, so these topics are pretty much important, and this is the topic where students have little difficulty, especially Nyquist plot. So in one full complete class I am going to explain you what Nyquist plots actually are. Okay, and how Nyquist plots were developed, what is the Nyquist stability criteria, now why the Nyquist stability criteria is n equal to p plus minus z plus. If you have heard before, if you have not heard before, we are going to go to that chapter. So if you have heard before, what is the Nyquist stability criteria, why does it come so, how does it come so. Okay, number of encirclement may we take the number of encirclement of the point -1, 0. We take the number of encirclement of the point -1, 0. Why we consider the -1, 0? Every secret about the Nyquist plot I am going to open. Okay, so I am going to explain you the sketching of the Nyquist plot, and apart from that I am also going to tell you the basic thing that led to the Nyquist plot, how Nyquist plots evolved, why this formula has been involved. Okay, the complete A to Z that we are going to do. Okay. Yes, they are not exclusively, Yashan, they are not exclusively a part of the syllabus now in GATE, but yeah, I am going to take an examples of them to make you understand. Okay, so you don't expect any questions from like modeling. What you're telling is little towards modeling, but not to go towards the modeling. Yeah, definitely some mechanical systems like spring mass damper systems, and in electrical, suppose if I take RC circuits, RLC circuits, because practically also I'll relate ki whatever you are studying, how it is applicable on the RLC circuit, how it is applicable on a spring mass damper system. So I'll keep taking these examples and to understand the things practically. Officially it's not a part of syllabus. Now don't expect any questions from there, from the modeling part. Is that okay, Yashan? Okay. Now after learning about stability, time response, etc., we move on towards the design of some control system elements, and within the design we divide the design into two parts. One is the controllers. Controllers are the elements, controllers are those control system elements which are introduced in the control system, which are designed in the control system to achieve a specific property. For example, you want to design a control system. It's all about designing for betterment. So suppose you want to design a control system to have a better speed. Okay. Yes, Arun Krishna, everything in this course will be with proof. Yes, everything. I told the Nyquist is one of the most important and complicated thing to understand, but I'm going to take a proof of this. That means I'm going to take the proof of the whole thing. Everything will be with derivations. According to my knowledge also, concepts are understood with the derivation, and GATE is a more or less conceptual paper. Okay, it's not a formulas based paper, and you will learn that in the control system several conceptual questions, especially two topics are there where lots of conceptual questions have been put up. One is the Nyquist plot. Okay, several conceptual questions are there from the Nyquist plot. You will be able to answer only if you know the concept behind Nyquist plot. Not only sketching is important, but if you know the concept. And also this topic root locus has also several conceptual questions. So to understand the concept you need to see how it has come up. वो निकल के कैसे आया है, जब आपको A to Z पता होगा तब आपका concept clear हो जाएगा. Okay, yeah, so everything will be with proper derivations. So suppose you wanted to design a control system having better speed. Now what do you mean by better speed? For that I will define a parameter known as settling time. Okay, suppose you want to design a control system having better accuracy. The speed, as I told, related with the settling time, accuracy related with the steady state errors. Suppose you want to design a system having low overshoot. For low overshoot, zeta is important. So I need to design a controller which is able to manage the values of damping ratio or steady state error or the settling time. Yes, Abbas, sure. It is going to go in that manner only. So you will be able to come to the design once only. या योगेश्वर बेटा अभी सब्जेक्ट स्टार्ट तो करने दो, एग्जांपल देंगे ना, डोंट वरी सो मच, थोड़ा स्टार्ट तो करने दो सब्जेक्ट को, अभी तो सिलेबस बता रहे हैं. So, no, you will be able to come to the design of control system only thing if you have studied everything about the control system, like what is speed, what is settling time, what is the error, what is meant by the overshoot, what is meant by the damping, how to control them. First, you know the basics about them, then only you can design a controller. You will be learning various controllers like proportional controllers, PD controllers, PI controllers. Yes, Meet, correct. And a fan में भी controllers होता है. What type of controller? Everything we'll look into this case. We have PID controllers. Okay. On what principle fan controller works, that we are going to see. Okay. So what are PID controllers? What is a tachometer controller? Okay. And then we move towards the compensator. See guys, what happens? Suppose you wanted to make a system more accurate. Listen. You wanted to make a system more accurate, and to improve the accuracy of the system, you reduce the steady state error of the system. You reduce the steady state error of the system. And you are happy that yes, I have reduced my steady state error. How to reduce that, I am going to tell you later in this chapter. So you are happy that yes, you have reduced the steady state error. You have improved the accuracy. But sometimes what may happen while reducing the steady state error or by improving any one of the thing, the stable system gets converted into unstable system. From stable systems, you end up in converting that stable system into an unstable system. Or maybe you are reducing the stability of the system. How do we measure stability? Gain margin and the phase margin. I told you the quantity of stability is going to be measured in the form of gain margin and phase margin, right? So you converted a stable system into an unstable system or into a less stable system. That means to achieve one thing, you have compromised other thing. To achieve one parameter like accuracy or speed, you have compromised other parameter of the system. Okay. And how much accurate the system may be or how much better the speed may be, if you are talking about an unstable system, it's practically of no use, because I'll talk about stability actually in the upcoming class, but unstable system is practically of no use, because even under the application of finite input, unstable systems gives an unbounded output. Unbounded output means infinite output. Okay. It's an output which cannot be controlled, which is an output which cannot be measured, and such unstable systems are practically of no use. So suppose you say, yes, I have achieved a good speed, but it's an unstable system, practically of no use. Okay, so sometimes if the stability goes away, if it is at the risk, then we go towards the design of compensators. Compensator का मतलब क्या होता है? If I talk the meaning, to compensate for a loss, हर्जाना देना. If I speak in Hindi, हर्जाना देना, compensate करना, to overcome for a loss. So yes, while improving the speed or accuracy or the overshoot of a system, you have lost the stability of the system and you have to overcome the loss. Okay, so to compensate for the loss, to compensate for something, we use compensators. And what are the compensators that you are going to study is the phase lead compensator, the phase lag compensator, and the phase lead lag compensator. The phase lead lag compensator. Okay, so these are the various compensators that you are going to study to compensate for a loss that has happened in the system. So that's about the design section, design of the control system. And after designing, we move towards the last chapter, one of the very interesting, state space analysis, also known as the modern control theory. State space analysis basically refers to the modern control theory. Okay. And in the modern control theory, first of all, why do we move towards the modern control theory? Because up to this point, that means before the state space analysis, all the things that in the time response, in the Nyquist plot, Bode plot, root locus, everywhere you are going to talk the transfer function of a control system. Control systems are mostly defined in the form of transfer function. What is transfer function? How it is applicable or not, that we are going to just discuss right now. But transfer function, transfer function model has some disadvantages. What disadvantages? वो आपको समय ही बताएगा. I'll tell you with time. And to overcome the disadvantages of the transfer function, there are several systems on which transfer function cannot be defined. And then such systems where transfer functions are undefined, we talk about the state space models where the transfer functions fail. where the transfer functions fail, where you are not able to define the gain of the system, you will be defining what? You will be defining the state space model. So I'll explain you what are state variables. There are several shortcuts to form the state space model. So there will be so much of shortcuts involved in this analysis. We'll take the proper method also, and conventional and shortcut methods also. Okay. Yes, Shreya, you are correct. One of the disadvantages of transfer function is MISO system. Okay. There are actually 3-4 disadvantages. 2 are very common. One is commented by Shreya. Can anyone comment one of the common disadvantages of transfer function? Transfer function, one disadvantage, it is applicable only for SISO. Single input, single output. One of the most common disadvantages, it is applicable only for single input and single output systems. If there is more than one input or more than one output. Okay, so Shreya, it can be MISO, or it may be SIMO, more than one output, or it may be MIMO. If I talk about these 3 cases, transfer function can't be defined. Transfer function can't be defined. Okay. Transfer function, yes. Exactly. It's applicable only for LTI systems because it comes up from something known as convolution. Okay. And yes, Yugandhar, that is correct. Yugandhar Grish, initial conditions are, if the system has non-zero initial conditions, non-zero initial condition, that means the transfer function cannot be defined. Okay, transfer function cannot be defined. Okay, so the transfer function can be defined only for LTI, only for SISO, and only for non-zero initial conditions. Okay. No, Durbadal, when initial conditions are not zero, transfer function can't be defined. Can't be defined. Okay. But in the state space model, non-zero initial conditions can be taken. No worries, Rahul or other, if you are not aware about this, I'm going to make it proof. I'm just having a, it's an introduction class and just having a discussion of whatever the things you are going to see. Okay. In this syllabus slide, don't see that I've completed anything. I'm just discussing generally. If you know, very good. These are basic ideas. If you don't know, we are going to discuss it anyways. Okay. Anyways, so state space model are applicable for non-LTI as well, for non-zero initial condition. Very important. You'll be able to deal with the systems having non-zero initial conditions. Okay. Then we talk about the transfer function decomposition. Matlab, how to convert transfer function into state space model. How to convert transfer function into a state space model. Okay, into a state space model. Then we have an important topic of controllability, observability, and then the time response analysis, especially for non-zero initial conditions. Okay, especially for non-zero initial conditions to be studied using the state space model. Now, most of the good questions are from this. Controllability, observability, and formation of state space model has questions, but for them, I'm going to give you very simple tricks. Okay, and by that tricks, the question is just going to become for you an observation question. Just look into the question, recall apne class mein kya padha hai, you are going to apply on the system. Clear, everyone? So that's what the complete syllabus of control system is. I have spoken about the weightage of this in the GATE and ESE exam both. So with respect to both the examinations, it has good weightage. It is an important subject because even some of the stability criteria that you study is applicable for analyzing other practical circuits that you study, in like analog circuits you study. So there are analog circuits, even in the analog circuits, if you want to test the stability, so you can there are models like Bode plots and Nyquist plots which are used to judge the stability of analog circuits as well, right? No, Vishnu, it's not a tough subject. Just wait for few days. It shouldn't be a tough subject. Okay. Yeah, Sindhu, it has a decent weightage in ISRO. Somewhere around 10 to 15 questions. 10 to 15 questions. That's what I'm able to recall. I'll take up the exact data also. I'll take up the exact analysis. But yeah, I go through the ISRO papers. I'll take some ISRO questions also in the class. I have some ISRO questions. But anyways, most of the ISRO questions are even copied from the GATE domain GATE exams also. But yeah, approximately around 10 to 15 questions you can expect. Okay. Yeah, Arun Krishna, you are going to understand that ki kahan applicable hai. Let me start with that. Achha, dear students, one thing I'm going to tell you in the beginning of the course, and that's actually going to be true, because yeah, Yes, Karthik Sai, in instrumentation, you have to study the process control separately. That is not going to be dealt here. Okay, you have to study it separately because this is a EC, and obviously, you know that we are going to focus with the EC and electrical thing. Process control is a separate topic. Maybe if you want help, I can provide you extra inputs or extra notes. Okay. Yeah, Satya and others who have commented in the beginning. Okay. Yeah, Karthik Sai, I can, if you want, you can take the help separately. You can contact me on the GradeUp app, and no, I will try to provide. Ask the team to give you the notes at least. That will be done, no problem. Okay. Yes, Mihira and Satya, I've noted your comments. I'll inform to the team immediately today evening. After the lockdown, you can be able to, if possibility time changes is there, I'll talk about the team and then I'll inform you. That's I'll have to talk about the course designing team. That's in their hands. But yeah, definitely I'll give my inputs. That is taken from you. Yes, Sindhu, same thing that we have followed in mathematics. I'll inform to the new students. Dear students, whatever topic I start, please give me some time to explain that topics. Because actually what happens in a class, there are three types of students. चलिए basically मैं first two type of students की बात करता हूँ. Number one, those who have a little bit idea of the subject, पहले कभी पढ़ा हुआ है थोड़ा बहुत. Okay. So they have a curiosity of going forward soon, and there will be vast variety of students, as you are already you are commenting that, sir, we have not studied the control even in the college. No worries, it's not a big concern for you, not a big concern for me. आपने पढ़ा है नहीं पढ़ा है, don't worry, because even the college studies are totally different. Even the college studies are totally different from the gate level. So I don't rely on the college theory. College theory is like college studies is mostly bookish. ठीक है, it's mostly memory based. ठीक है, mostly memory based. Okay. Rohini, I usually try to avoid, but as you know, as you have enrolled in the target, it's a bilingual course. But still, I try to avoid that. Sometimes some words may come up, but no worries, it's not going to hurt your course. That is my guarantee. The course, the technical is everything A to Z English, so it's not going to affect your course. No worry if you are a second year student. Even if you are a pass out student and if you have studied controls only in the college, now I think that is not sufficient. College studies are totally different. In gate and engineering services level study is different as compared to college for any subject. Okay, for any subject. Now, once I start taking anything now, so there are many students who even don't know the basics of this subject. So let me complete a portion and then put up your comments. Okay, because I told you everything will come up with the derivation. We'll have proofs and we'll have derivations for everything. Okay. So while I'm explaining, please hold on your comments. And then let me complete. Then if you are able to, then if you comment, that's fine, so that I'll able to read. Because meanwhile, if I'm deriving something, if I'm concentrating only on the screen, I may not be able to read your comment also. So that's a loss for you. That's a loss for everyone. Okay. Apart from that, I know regularly, guys, you will be asking about theory books. Regularly, you'll be asking me, you'll be definitely commenting me about theory books. Now listen. In this subject, control system, in this subject, nothing. If you just follow A to Z of the live class, just follow A to Z within the live class. Just follow A to Z within the live class. This is my assurity. You don't need. There are some good books I can suggest you. Very famous book for control system is Benjamin Kuo, one of my favorites. But still, with respect to a student level, even Kuo will not cover 100% of the cases. See what is the problem with the textbook, especially for competitive exam. Some cases will be good in some books, some cases will be good in another book. And as a student, how many books you are going to study? And you don't have to study only one subject. If I talk about the GATE syllabus only, it's approximately 10 to 11 subjects, right? Only GATE syllabus. ESE has more subjects. So for every subject, if you start taking and studying 3 to 4 books, so for you, it will not be that much of time. You will be able to manage. But at least in my subjects, I'll assure you, the control systems as well, and even the other subjects that I take later on, you will not require any textbook. That is my assurance. That means all definitions, all theorems, all derivations, etc., will be given to you within the class. That's only your theory book. Matlab, only theory that you require in your revision is your class notes. Because I have, I have studied several. Yes, Shai Shri, more or less it is sufficient. I have gone through several control system books, and the content I give is totally, a collection from all the books. Best knowledge from each and every books will be given to you. So just class notes will be sufficient. And for class notes, I will give you time, like I have given in mathematics. I've given in mathematics. I'll give you the time to take screenshots. Okay. So I'll just continue with the topic. I will explain that topic full, and then I'll give you 2 to 3 minutes to take the screenshots. So again, what you can do is, okay, yeah, Shiva Shankar, better than taking running notes. See, running notes mein you will take a lot of time in writing. Okay, you will take a that's also good. That's also good, Arun Krishna. But I tell you now, even the best book is also not required. Just follow this classes. Just follow this classes. Even, if you are taking, what I only suggest you to you is take a rough notebook. That is sufficient. Take a rough copy with you. Okay, to solve questions. Obviously, take a pen with you. Okay, to take a pen with you. Even questions you have to solve in a rough copy. And I will also give you the solution of every question. So you can take the screenshot of the solution also. Okay. Screenshots of both theory and questions. I'll give you time to take the screenshots of both theory and question. Okay. Yes, yeah, even some of you are familiar with my methodology, Sunil, but I'm telling for the newcomers as well. I'll give you time to take the screenshot of theory and question. What you have to do in your laptop or in your mobile. Okay. Just make a folder. Just make a folder by the name of control systems. Just make a folder by the name of control systems. Okay. Yeah, Durbadal, just wait. I'll tell that also. Make a folder of control systems. Make a chapter like introduction chapter, and save your respective screenshots, images there, so that you have a folder-wise arrangement. I think that is sufficient. You don't have to go open any textbook. All cases, derivations is going to be there. So, dear students, I'm telling this for your reference only, to save your time. Otherwise, unnecessary, you'll go and study some books not required. A to Z questions of A to Z theory and 0 to 100 level of numericals. 0 to 100 levels of numericals is going to be covered in the class. Okay. Now for practice, Sheikh live class, quiz and mock test to minimum hai. I'll tell you some more thing. Okay, so 0 to 100 level of numericals I'm going to cover in the class. Matlab starting with the basic questions. Sometimes 2 marker maybe simple question aata. Sometimes you have a good conceptual question, thoughtful question. So everything I'm going to cover here. So just my request to you students is, yes, Saurabh Kumar, no need to make notes separately. See, everything important derivation and theory mein type karke layo. It is there typed. You are just going to copy that. Some questions I am going to solve, and my handwriting, when I start solving question, don't worry, I'll have a pretty decent handwriting. So you can take the screenshot. Why do you want? Because that is just what happened. Suppose if you take the screenshot in 2 minutes, you are going to take at least 5 to 6 minutes. At least 5 to 6 minutes to take the notes. And the time you waste in making notes, I know notes are important, so I am not skipping. And because they are important, screenshots, I am giving you time for screenshots. But the extra time you make in writing, that extra time we can dedicate to solve more questions. That is what my intention is. मैं क्यों time बचा रहा हूँ? ऐसा नहीं कि notes नहीं दे रहा हूँ. Notes are given to you in the form of screenshots. In the form of screenshots. ठीक है. So maybe जितना आप नहीं लिख पाओगे, उससे more than that you will get in the screenshot. Right? Yes, and those who have studied mathematics, as Yashwant is commenting, yes, that is a good way of just making the notes. Don't worry. So take the screenshots. जो time save करेंगे उसमें हम ज़्यादा question करेंगे, and more question means more practice, and ultimately competitive exam is all about practice. First concept and practice. Okay. Definitely, Sunil. Pictures, आपको सारा software available है. Download the softwares and you can can convert the pictures into PDF. Maybe if you want, take a printout of that also. Everything is feasible. That's on to you कि आप क्या करना चाहते हो. But I'll give you time for screenshots. And all levels of numericals to be covered in the class. All levels of numericals to be covered in the class. This is about theory books. You don't need any theory books. Okay. Now next, your question that is going to come. मैं इसलिए beginning में clear कर दे रहा हूँ, so that you keep on commenting. You will next ask about some practice, where to do practice. So just wait for, let me begin. Right now I have not started. Right now I have not started anything. I have not started even theory. I have just give you the introduction of syllabus. For practice books, okay, for practice books, just wait for 2 to 3 days. Maybe by Tuesday, okay, maybe by Tuesday I'm going to unreveal this कि from where to practice. But practice के लिए let us start something at least. अभी तो practice करने लायक कुछ है ही नहीं. Okay, so let me start something, then only you will be able to think about practice. Okay, so I'll just give you the information within 2 to 3 days कि what all is necessary for you to to practice for control systems. Okay, so that will theory and practice. I've spoken both. I've spoken this earlier because I know regularly students will keep on asking. Okay, so theory book is nothing required. Just take on following the live classes, take the screenshots. I myself am going to tell you when to take the screenshot. After completing a topic, I'll give periodically I'll give time for screenshots. Practice books, wait, Tuesday, Wednesday. By Tuesday itself, I'll tell you the practice criteria actually. By Tuesday itself, I'll tell you the practice criteria because this first class is introduction, not many numericals. Second class, yes, block diagram, we have some numericals, and then the important signal flow graph, that is on Tuesday. So for there, we have completed some topics. So then it is, meaningful to take some practice books, right? Right. So just keep your patience. I'll tell you everything. I'll tell you everything. And guys, now let's get started with subjects. What do you first of all understand with the control system, and what are the two basic categories of the control system? There is little knowledge required of the Laplace transform. Okay, there's little knowledge required about the Laplace transform, and I know that this batch has not gone through the signals and systems course. Laplace transform आप पढ़ते हो signals के course में, right? You study the Laplace in the signals and systems, and I know target batch has not gone with signals and systems. So I'm just going to take a basic review of Laplace transform. Only few formulas and properties you need, not the complete. Laplace transform detail may you will study in the signals and systems course. But here, basically you need some basic formula and properties so that you are comfortable with the understanding of transfer function, and the time response also we use some Laplace transform. So whatever is required, I'm telling you. That's why I told you, don't worry, there is no going to be any prerequisite of this subject. Only thing is basic knowledge of Laplace transform is prerequisite of this subject that I'm going to discuss with you within this class only. I'll give you the hint. Very quickly, I'll give you what is required. Okay, so that you are comfortable with the control system. Rest about Laplace, you will study in signals. Okay. Yes, Alia, can you refresh? I think the video is working parallelly. Yeah, guys, so just let's take an example. I know many might be knowing Laplace transform आपने engineering maths में भी पढ़ा होगा in the first year. Okay, so I know many will be knowing basic and not also the typical Laplace cases, very basic Laplace. Okay. Because Yugandhar, Fourier transforms are applicable only for stable systems. Yugandhar, Fourier transforms are applicable only for stable systems. For unstable systems, you can't define the Fourier transform. Okay, but Laplace can be defined for stable as well as unstable systems. So that is why we are taking Laplace. Fourier is because control system, a major thing in control system is all about determining stability. So given a system, we don't know whether it is stable or not. So how can we apply Fourier transform? We can't apply Fourier transform unless and until we are sure that it is a stable system. Okay, that's one of the most basic reasons I have given you, Yugandhar. Fine. So dear students, just starting with an example. Understand? I'll give you the notes then. Suppose this is a flat road, and then there is a gradual turn. Take it, gradual turn. Okay, I'm starting. Okay, I'm starting now. So dear students, just hold on for the comments now. Otherwise, we'll not be able to start with the topic. So there's initially there's a flat straight road and it has a turn. It has almost a 90-degree turn. Okay. And suppose that you are driving your car or your motorcycle, anything. Let's take car. You're driving your car. Suppose you're driving your car. Just imagine this is your car. That's it. I'm taking a rough diagram on this flat road. Now listen, everyone. You're driving your car on a flat road, and you're moving forward. You're progressing forward. And then after you see that after a certain distance, there is a turn. There is a turn available. So what is the immediate thought that will come into your mind if you are driving the car? What is the immediate thought that will come into your mind? The immediate thought is, I am seeing a turn, the road has a turn. So obviously I will need to turn my car. Okay. Obviously I'll need to turn my car. So looking into this situation, before I give you the definition, I'm taking an example. Okay. So just looking just looking, there's an objective set into the mind. Objectives later, yeah, obviously logically will slow down, but most important thing here is talk about the most important objective, that you need to turn. Obviously for turning the car you will apply, you will use the steering and you will have a little brake mechanism. Okay, so what is the objective set into mind? The objective is turn the car. And turn the car matlab turn how? Using the steering. How do you turn the car? Using the steering. So there is an objective set in my mind, and to fulfill that objective I apply the input to the system. I apply the input to the system, and that input is applied where? The input is applied where? On the steering. Let's say some angle. The input is some angle by which the steering has been rotated. Input is some angle by which the steering has been rotated. Okay. So now what is the output point? What is the output point? Where is the output here? Obviously, once you give the turning on the steering, your wheels will also rotate proportional to the angle at which your steering has been rotated, right? So you get, suppose I define the output as the turning of the wheels. Output as the turning of the wheels, right? Suppose I define the output as the turning of the wheels. Correct, everyone? Okay. Yeah, the turning of the wheels. Now, what about the mechanism? What about the accuracy of this whole system? Suppose that you are driving this car for the first time. Now, there are two situations to understand. Okay, I'm just defining basically control system को define करने की कोशिश कर रहे हैं हम. So suppose you are driving this car for the first time. Matlab you are a first time user, means you are an inexperienced user. Okay, you are an inexperienced user of this system. Okay, so suppose a car has almost come here, and because you are inexperienced user, what may happen? What may happen if you are an inexperienced user? Okay, suppose you're driving the car for the first time and you don't know, you just panic. What happens? Suddenly a turn aata hai, so you may panic because you are driving for the first time, and because you may panic, so you may apply the incorrect input to the system. What I mean by incorrect input of the system, it may be very less input or it may be very large input as compared to the required input value. Okay, suppose you panicked, and these days modern cars are mostly equipped with power steering. So let us say you are driving a car having power steering with a very smooth steering. Okay, so suppose you just panicked. There's a turn and I need to rotate my steering, and you rotated it in large amount. Okay, you rotate it in a large amount, and what happens is, okay, you go and collide with this wall. Suppose this is, it is a boundary. It's not a field on the other side. It's closed by a boundary. There are walls on both the sides. Okay, and what happens? You may have a collision occurring here. You may have a collision occurring here, and that means there is a damage to the system that may occur. Okay, collision obviously means the damage to the system that may occur. Is that clear? Or maybe the other possibility is that you apply very low input. Okay, your car travels forward, and you apply very less input, and due to which the collision may occur here as well. Okay, so if you are using the system for the first time, and if you don't apply the correct input, the output, the whole system may collapse on a whole. Getting the idea? The whole system may collapse on a whole. Had you been an experienced user, अगर आपको बहुत अच्छे से कार चलाना आता होता, if you are pretty much experienced, suppose you have been driving car for months or years, then would this problem occur? Most likely no. Most likely this problem will not occur with the experienced user. Exceptional case में हो जाता है sometimes, no. But mostly with the experienced user, what an experienced user, if you are a good car driver, just imagine yourself, so will you do such collision? Most likely not. 99.9% no. Okay, just I leave 0.1% ki maybe some obstacle came or you just lost your concentration, usko neglect karte hue, mostly you are not going to have the collision. If you are an experienced user, you will give a proper, because experience means what? You know how to deal with what, by how much amount I should rotate the angle so that I get into the proper track, proper turning, if I follow the proper radius. Okay. Yeah, that's what Shiva Shankar I told, and that is exceptions, so not talking about exceptions. Okay. That not talking about exceptions. Okay, so normally the collision will not occur if you are an experienced user. Okay, So one thing, how to handle the system better? How to handle the system better? Firstly, is to have an experience. Or suppose if you don't have experience, now thinking hypothetically, okay, I am going to actually take a more practical example. Just wait, I am going to give you a more practical example. But just thinking hypothetically, just listen to me. What can happen? What can happen? Ki suppose it's a funny situation. आपको हंसी आएगा सुन के. But suppose you are inexperienced and still how the collision can be avoided. How the collision can be avoided. Suppose you are inexperienced, but there is one of your friend who is sitting on the wheels. Hypothetical, practically not possible, but imagine. It's a funny situation, but imagine. There is some of your friend, ठीक है, there's some of your informer who is sitting on the wheel. आपने किसी को wheel पे बिठा दिया है कि boss, I don't know how to rotate, how to handle the steering properly, how to handle the steering properly. But you are sitting on the wheel. Just imagine, if you want to laugh, you can laugh. But just imagine and think about the concept I'm trying to tell. Concept को सोचिए, ठीक है? Then I'm going to convert it into a more practical case. Obviously, that's making someone sitting on the wheel is not practically possible. But हम उसको करेंगे. We'll take a more practical example. So, what is the role of that person sitting on the wheel? Just think, what is the role of that person? So, what is the role of that person? That because you are inexperienced, you may apply more input or you may apply less input, and under both the cases, collision may occur. And if you apply more input, or correspondingly the output will also be more. जितना ज़्यादा steering को rotate करेंगे, that much amount wheels will also rotate. Wheels will also turn. So suppose the wheels are turning more. They are going out of track. It is going towards collision. So that friend, you are connected, suppose via call. That friend is connected to you via call, and he's just going to give you an information ki, buddy, you are doing wrong. Okay, you are going to do wrong. It's a collision going to occur. We'll collapse. So please correct yourself. Please correct what? Please correct this thing. It's actually a mechanism to correct the input if the input is going wrong. The system is okay. The system is what you design. You will learn about the designing of control system also. But I'm talking with respect to the user level right now. How a user can handle a control system. So that buddy who's sitting in the phone connected via a call, उसने आपको inform किया कि boss, you are doing wrong. You have applied a lot of input to the steering. Just reduce it. So he may try to reduce it, and maybe you are going to avoid the collision. Okay. Okay. And what this information is about? Yes, Nihar and Shiva Shankar, the correct word. Okay. Yes, Sundar, correct word. This information is nothing but known as the feedback information, the feedback signals coming into picture. And once you have feedback in the system, once you have the feedback into a system, you call the system as closed loop system. The earlier system, I'm going to give the definition now. The earlier system was actually an open loop system, where open loop system means what? You apply an input and you measure the output. That's it. Okay. But the value of the output does not change the input, because there is no one informing the output. A first case, without that friend case, you are alone. Okay. So the output obtained on the wheels, I am not measuring. मैंने केवल input apply किया and I get some output. But whether that output is right or wrong, I am not getting an information. There is no feedback, and such a case is known as open loop system. Okay. But if you are measuring the output continuously, who was measuring your output? That friend, and who is giving in information through a phone call. Okay. So if you are measuring the output continuously, and what is the purpose of measuring the output? Okay. What is the purpose of measuring the output? Exactly, Vikas. That can be thought as a case. What is the purpose of measuring the output? The purpose of measuring the output is to make a correction on the input if the input is not correct. Okay. So if you measure the output to control the input, to correct the control action of the input, such a case basically becomes the case of a closed loop system. Okay. Now, obviously, logically, you cannot make someone sit on the wheel. That was just a funny situation. कि क्या सोच सकते थे? Just about thinking. But now let's take another example where I'm going to take a proper case to distinguish between open loop and closed loop, and which of them is better, which of them is not better. Let's understand that. Okay. So introduction. Introduction. And then just starting with few definitions. We'll take the screenshots later on. I'll tell you when to take the screenshots. So as I told, the basic objective of any control system is to control a particular action Just a second. The basic objective of any control system is to control a particular action in a predefined manner. Right now, I am telling you the definition of control system on the upper level. That means the system has been designed, but we being the technical guys, we are going to look into the inside the system. And as I told you, we have one chapter known as the design, where you understand how to design the control system elements. But that will be dealt later on. Designing baad mein dekhenge. But first of all, what is the upper level definition of a control system? Okay, so you want to control a particular action. What was that particular action? You need to turn the car. Why you need to turn a car? Because there was an objective set in the mind. What was the objective? Because there is a turn in the road, I need to turn my car. Okay. And how will you complete that action? By applying an input. And through the elements of the control system. For example, what are the elements of the control system in that car example? The internal steering mechanism which is connected to the wheel. The internal steering mechanism of the car which is connected to the wheel, which has been designed right now. I'm talking on the upper level. We will go into the designing also step by step. Inside the system also we'll go. Okay. So we have an input. Okay. And the input is applied on the control system elements and we get some output. But we are not measuring the output. Now, that is what the two differences coming upon. So my dear students, I'm going to take one more example to make the difference between open loop system versus closed loop system clear. And then I will give you the definition between open loop system and closed loop system. Okay. I'll give you the definition and differences between open loop and closed loop system. So just keep following. No, open loop versus closed loop. So take one open loop control system. Suppose you have an electric clothes dryer. Just a moment, students. Yes. Yeah. So suppose you have an electric clothes dryer. What do I mean by electric clothes dryer? Is a machine which is whose role is just to dry up some wet clothes. Okay, so you have washed the clothes separately. Aapne wash kar liya clothes ko, that you have done separately, and now you have some wet clothes and you want to dry the clothes. Okay, and for that you have a machine known as the electric clothes dryer. And obviously, what can be the most important element of an electric clothes dryer? The most important element of an electric clothes dryer will be the heating elements inside the machine, which is responsible for increasing the temperature inside the machine, and because of that heat inside the machine, the clothes will be dried up. Okay, so what is the objective set in your mind? That you have some clothes and you have a required dryness. Matlab you have some clothes and you need to dry them. You are required to dry them. Okay, what are the inputs? The inputs to the system may be a timer or a temperature or both. Okay, timer or temperature or both. So suppose you have a set of clothes, around 8 to 10 clothes. Listen to me carefully. Suppose you have a set of 8 to 10 clothes, completely wet, just now you have washed them, and you dump it inside the machine. Okay. You have set a temperature. And suppose the actual time required, just listen very carefully. Suppose the actual time required, according to the clothes you have fed, is 30 minutes. Now, it's an automatic clothes dryer. You set the timer for 30 minutes. Okay, you set the timer for 30 minutes. You go away. Okay, you do any of your other works. आप कुछ और काम जाके कर सकते हैं. You do your other works. And at the end of 30 minutes, automatically the machine is going to raise an alarm or a bell, something like alarm. That is going to give you an idea that yes, the timer, the 30 minutes has completed. Now I can go and take out my clothes and I will see whether my output has been obtained or not. What is the expectation that you want? Yes, all the 10 clothes should be totally dried up. That is what your expectation is. Okay. But dear student, the same thing. Suppose if you are a first time user. That same inexperience I am talking about. Suppose if you are a first time user. Okay. So you may not know. Suppose आप अपने ऊपर imagine करो कि you randomly buy an electric clothes dryer and today you are going to use it for the first time. So will you have the clear idea? Ki suppose this is the quantity of clothes, this is the quantity of wet clothes, how much time is it going to take? You will have the clear idea once you have used it repeatedly. If you have experience, suppose you are using it for 2, 3, 4 months, then you have clear idea. But suppose today you are going to use it for the first time. Okay, I don't have any idea. So maybe what will I do? I will just set my timer on 15 minutes. because I don't know. Randomly, I just set my timer on the 15 minutes. That means incorrect input. Same thing that we have done here. Incorrect input that led to the collision. That led to the collision. So here also you apply, because you're a first time user, you thought I don't know the exact time required. So you just randomly put it as 15 minutes because of your inexperience. Okay. And then you go away and do your separate works. Automatic control system, it is going to raise the alarm automatically after 15 minutes. And then when you hear the sound of the alarm, you will come back to the machine, and what you will expect, ki my clothes should have been dried. My clothes should have been dried. But will it actually happen? Will it actually happen? Will your clothes be actually dried up? Will it actually happen? Yes. The actual time is 30 minutes, but because you are inexperienced, aapne timer only 15 minutes you have set the timer. What is the output you said? Ki the clothes are, the output that you see that the clothes are just partially dry. The clothes are partially dry and partially wet, right? The clothes are partially dry and partially wet. Clear, everyone? So obviously, you will have to again set the timer for another thing. Matlab, in one single shot, your task is not completed. You can again set the timer, that is okay. But in one single shot, your task is not completed. Okay. And also what may happen, suppose there is another first time user. This is situation A. Consider situation B. Another first time user who is using the machine for the first time. Okay. And who will set the timer to 60 minutes. Now, inexperience means inexperience. You don't know how much time is required. And in the first situation, I imagine the person who set the time 15 minutes. There may be another person, he is also not aware about the machine, and what he will do? He will set the timer for 60 minutes. Okay, what may happen now? What may happen now? Yeah, Shubham, we are going to talk about that feedback only. What may happen now under this situation? Yes, Ramya, correct. What may happen? There's a possibility, because the clothes actual time required to dry it up is 30 minutes. Okay, 30 minutes is the time required, but you give the machine a time of 60 minutes, and within the 30 minutes itself, the clothes are dried. But you give another double the time, you give the machine to generate more heat. Okay, the machine generate more heats in the additional 30 minutes that may has a good chances of damaging the clothes. Okay, there is a good chances that the clothes may be damaged. Again, the system is damaged, like the collision case. It's like resembling to the collision case, yes, where we have some damage to us, right? Clear? The clothes get dry, definitely they dry in 30 minutes, but because of the extra 30 minutes, the clothes may also be damaged. So in either of the case, yeah, Meet, why we give 60 minutes? Because you are first time. Okay, because you are a first time user, you don't know na. 30 minutes is just, I'm telling you, imagine the actual time is 30 minutes according to an experienced user. Suppose I have been using this. Yes, Shubham is exactly coming with the correct answer. And that's what, that's what I'm thinking, taking this so that you also come up with the idea of what can happen, what should be done in a system. So Shubham is just commenting on that. That's good. Yeah, so Meet, suppose I have been using this machine for around 5 to 6 months. I know the actual time is 30 minutes. But Meet, because you are using for the first time, you don't know na. आपको तो नहीं पता, you don't know, so you randomly set it. Maybe 15 minutes, maybe 60 minutes, maybe 45 minutes. Okay. चलिए. अरे Meet, company वाले can take all time, because this was the required dryness for, suppose I told 10 clothes. Suppose if you have more than 10 clothes, suppose if you have more than 20 clothes, then the timer may be more, na? Then the timer may be more. So, yeah. Let's come back and explain the system. Let's follow the definition. In an open loop control system, now this is what is an open loop control system, like the car example. Okay, like the car example. In an open loop control system, the output has no effect on the control action of the input, like this clothes example or like the car example. You applied open loop control system is that car example also. If you applied the input, okay, but you don't know where the output is going, okay, and you don't have any information about the output. The output has no effect on changing the input. How can the output have effect on changing the input? When you have your friend sitting, on the wheel, that is giving you the feedback, okay, and when feedback comes into the picture, that is closed loop system. But right now it's the case of open loop system where the output has no effect on the control action of the input, because you are not measuring the output at every point of time. You are just coming in the last and seeing what the output is, right? And what are the two major drawbacks of this? I'm going to talk about more differences. I'll give you a table. What are the two major drawbacks of such a system? Number one, the accuracy. Okay, the accuracy depends on the experience of the user. Okay, the number one problem is accuracy. It depends on the experience of the user, like the car example or like this machine example. If you are well experienced, then the accuracy is maintained. Otherwise, damages may occur. Otherwise, the expected output is not at all meeting with the correct output. Matlab system is not accurate. The accuracy depends on the experience of the user. Number two, it is poorly equipped to handle disturbance. It is poorly equipped to handle disturbance. Now, why, sir? Why? This is the point coming up. Now, suppose, listen very carefully. Suppose you are an experienced user for the same clothes dryer. Suppose you are experienced user and you will set the timer now for 15 minutes. You will now set the timer for 15 minutes. Sorry, 30 minutes. Exact time, na? 30 minutes. Suppose you are an experienced user, you set the timer for 30 minutes and you confidently go away and you expect, okay, you expect that at the end of 30 minutes you will get the clothes as dried up. But what happens in between? Listen, again a funny situation. Suppose in your home there is a naughty child. Suppose in your home there is a naughty child. Okay. There is a naughty child, is like Shararati Bacha. He comes close to the machine. The machine is operating. You are away from the machine because you are waiting for the alarm to be raised. You will come after the alarm raises. So you are doing some other work. You are busy in other work. So you don't know what is happening near the machine. A naughty child has come. He sees something is happening, and out of curiosity, what he tried to do is, meanwhile, he tried to open the door of the clothes dryer, the front door from which you feed the clothes. Out of curiosity, out of his naughty nature, what the child did? He just opened the door of the machine. He observed what is happening, what is not happening. He didn't understand anything, but then he closed the door. Okay. So unwillingly, unintentionally, he opened the door. He opens the door of the machine for maybe 2-3 minutes only. And then he closes because he is not able to understand what is happening. He goes away. Now you are not even aware. That happened. You are somewhere else. But now will you get your correct output at the end of 30 minutes? Suppose 30 minutes are over, alarm baj gaya. Okay, there's a siren, there's an alarm raised. You come back to the machine with the expectation, with a happy mood. Yes, my clothes will be dried up. But will you get the correct output now? Please comment. Will you get the correct output under this situation? Will you get the correct output under this situation? No. The correct output will not be expected now. Why? Because within this 2-3 minutes, the heat that was generated, inside the machine, has been lost to atmosphere. Okay, and once he closes the door again, the machine will take some more time to get back. Okay, to get back to the same heat that was initially generated, right? Okay, so some additional time will be required to maintain that. And then what is this naughty child actually? This naughty child is nothing but a disturbance. Technically, the disturbance that we refer to as the noise. Okay, it's referred to as noise. Okay. Yes. So a noise occurs a noise occurs which deviates the output from the desired value, and you are not even aware because you are away from the system, and the system did not handle the noise well. Okay, it did not handle. Matlab the output will not be the correct output, and that is why I was mentioning the second drawback. It is poorly handled, equipped. There is no provision to handle disturbance. There is no automatic provision to handle disturbance. Up and at the end of 30 minutes now. At the end of 30 minutes, you will be wondering why the output is not correct. You will be wondering why the output is not correct because you don't know. Noise is a random phenomena. It may come, it may not come. When does it come? How does it come? In what form does it come? We are not aware about that. Okay. Yeah, Jyotsna, your point is correct, but we are talking about with respect to user level right now. So we are taking into the fact that machine is okay, but still you are not getting the accuracy. So that accuracy you are not getting. Why you are not getting the accuracy? But one is because of the inexperience, okay, and one is because of the disturbance. But now listen everyone, now I'm changing. Yeah, just let me complete one topic, then we will take screenshots and then you comment. I'll reply to that. Otherwise, if I keep on commenting in between, though, we'll lose the track. So let me complete this. So what's a closed loop control system? So same thing, same system. See, what was there in the system originally? Only the heating elements were there. Look at this. Originally in the system, only heating elements I took. But now I'm modifying the system a little bit such that I have a temperature sensor fit inside. I have a temperature sensor fit inside the machine along with the heating elements. And guys, what is the role of the temperature sensor? What is the role of the temperature sensor? Is to measure the temperature inside the machine at every point of time. At every point of time. Okay. Okay. At every point of time. So suppose every point of time, that means it is just like a feedback mechanism, like the friend sitting on the wheel who is trying to give you the information. It's like the friend sitting on the wheel. Okay, so what is the role of the temperature sensor? Suppose that again the same thing, actual time required is 30 minutes, okay, but first time user has set the time to 20 minutes. Suppose now listen very carefully. So at the end of 10 minutes, okay, at the end of 10 minutes, listen, at the end of 10 minutes, what is going to happen? What will user expect? User has set the time to 20 minutes. So according to user, at the end of 10 minutes, 50% task should be completed. But actually, how much task will be completed at the end of 10 minutes? At the end of 10 minutes, it will be just 33%, 1/3 actually, approximately 33%. दोनों की टाइमिंग में डिफरेंस है ना, तो at the end of 10 minutes, user will be imagining that yes, almost 50% task will be finished. But actually, the actual time was 30 minutes. So at the end of 10 minutes, how much task is finished? 33%. So this temperature sensor is going to measure the wetness of the clothes, ki how much wet they are, and it will sense that the timer is only for 10 to 20 minutes. The timer is only for 20 minutes. 10 minutes have gone away. 10 minutes have gone away and only 33 output has been completed. Only 33% of the output has been completed in 10 minutes. Okay. And if I want to complete the remaining task in another 10 minutes, remaining task matlab 67%. So what it has to do? It has to control the action of the input. Now here, because this is just a block diagram study, we are going to talk about the details of the system within class by class, but this is just a block diagram view. What can come here? Number one, I need a comparator and a controller. Should not be or. A comparator and a controller. What is the role of the comparator? The comparator role is to compare the current value of the output and the required value of the output. Okay. So here the current value and required value does not match. Actually with respect to user, at the end of 10 minutes, 50% finish ho jana chahiye. But actually how much task is finished? 33%. So the expected output is 50% at the end of 10 minutes. But actual is 33%. They do not match. The actual output and the expected output do not match. Okay, the role of the comparator is to match the expected output with the actual output. And if there is a mismatch, compare them and then control. Okay, how it can control? It may be increase the temperature. Increase the temperature for another 10 minutes. It may increase the temperature for another 10 minutes so that in the another 10 minutes, automatically 67% of the task is finished. Automatically 67% of the task is finished. Okay. Or getting this idea, na? Okay, so that means this system has a provision, even that the user was inexperienced, it has a provision of giving you better results as compared to open loop. Maybe not 100% accurate, but slightly, but definitely much better than the open loop case. Much better than the open loop case because of the internal automatic feedback provision where the temperature of the clothes is being monitored at every moment of time. And also with respect to this child. Okay. You are an experienced user, you have set the time for 30 minutes as I've written on the screen. You are away from the system, naughty child has come, you don't know who has come, a naughty child has come, matlab a disturbance has come, heat has been lost to the atmosphere, now the door is closed. But earlier case, you didn't come to know that heat is lost to the atmosphere because it was open loop case. We are not measuring what is happening with the output. हमने केवल input apply करके leave कर दिया, that is open loop. You apply the input and you leave the system, that is open loop. But here, the output is being continuously measured, and definitely if the heat is lost to the atmosphere, internally temperature sensor is there. What is the role of temperature sensor? To sense the temperature. And if heat is lost to the atmosphere, obviously the temperature inside the machine falls. Obviously the temperature inside the machine falls, na beta. And if the temperature falls, there is someone sitting to measure to that temperature. That temperature sensor will sense, yes, temperature, for whatsoever reason, the temperature has fallen, so I need to increase the temperature. Okay, so it has the controller which is going to increase that temperature. Matlab, there is also an automatic provision. There is also an automatic provision to handle the disturbance. So let me give you the first definition of this. Okay, what is a closed loop system? Okay, so the one way in which we can accurately control the process is to measure the output. And feed it back. Important point, feed it back to compare the actual output with what is desired. Okay, and such a control system which uses the measurement of the output to control the action of the input is known as closed loop system. Okay, closed loop system. Yeah, it can come, Ambuj, it can come in a closed set. Disturbance means noise, it can come anywhere, but the system should be designed in a manner so that it is able to handle the disturbance. That child can still come and open the door. The disturbance was that child. The noise can come, but your system should be well designed such that it is able to handle that noise. Okay, it is able to handle that noise. Such a control system which uses the measurement of the output to control the action of the input is known as a closed loop system. Okay, is known as a closed loop system. Okay, closed loop system. Right now, desired output, Aruna, depends on, no, suppose for this example, it depends on the number of clothes you have. Okay. Yeah, Shubham, increase, as in it can increase the temperature basically. Basically, it can increase the temperature to achieve its target, to achieve the 100% target. See, maybe not 100%, but at least 95, 98%. 95, 98%. Okay. Now, look at this. Look at this table clearly. Yes. Now, this is a complete set of differences in the open loop and the closed loop system. Just have a view of this. Whatever we have discussed till now, I'll just, as a pointers, I have brought it for you. Okay, the accuracy depends upon the experience of the user. That is what I have told. Okay. It is generally more accurate. Closed loop system. It is generally more accurate because the error between the actual output and the desired output is measured continuously. Okay. It is easy to design and cheap, but the closed loop system is complex in design and costly. It is very logical why it is costly. Right? It is very logical why it is costly because The open loop system has only heating elements, but the closed loop system has a temperature sensor, has a controller, has a compensator. So to improve the accuracy, you are paying more cost. To be simple, you are making the design complex by adding more number of elements, and the design is also costly. You have to pay more. Okay. So open loop system, it's easy to design and also cheap in terms of money. Okay, and closed loop system, it's costly. Okay, the effect of noise, this noise means that same factor disturbance. The effect of noise means the disturbance is more in the case of open loop. Okay, more in the case of open loop, and here the effect of noise is less. That I've explained. Okay. Yeah, Meet, just wait. Why, stability icon? That's what I'm telling. It is more stable and it becomes unstable, and its stability can be increased. See, generally making a open loop into a closed loop, it may lose stability, but there are methods to improve stability. Meet, listen, everyone. There are methods to improve stability, and first of all, why it becomes unstable? That can be understood once I start the concept of stability. Once I start the concept of stability, you just have to wait for this point. Just have to wait for this point. It's going to clear with time. It is going to clear with time. No, once we go towards the stability methods like Nyquist or Authare, it will make it more clear why that is more stable, why the open loop is more stable, and what leads to instability. Okay. But yeah, even it becomes unstable, then there are some compensators to improve the stability. That's what we learn in the whole course. Okay. Every concept we learn in the whole course. This is what I'm going to talk in sensitivity topic. Okay. Just in the table I mentioned the point. Okay. Just in the table I have mentioned the point. It is more sensitive to parameter and it is less sensitive to the parameter variation. But why it is more sensitive and why it is less sensitive? The today's topic sensitivity which is there, the today's topic, the sensitivity which is there, it is going to make that difference clear. It is going to make that difference clear. The sensitivity topic, right? Okay, so this is going to be covered in the sensitivity topic, that is today itself. Stability I'm not commenting right now, just because I wanted to give you a difference for your notes. Okay, now what's the notes? Then Nandish, just wait. Exact reason for stability I'll explain you once we start stability. There you'll understand automatically. Okay, so I'm going to comment on stability once I start the topic. Otherwise, only not everyone will be able to understand without if I give you the definition of stability. So just only wait for this. First three we have seen. First three differences I have explained in the theory. This I am going to do today and this I am going to do later on. Right? This I am going to explain you later on. But just for the sake of notes, I have written all the points. So what we will do till now, guys, we'll first take the screenshots up to this slide and then we'll move forward. So now, as I told you, I'm going to give you the time for taking the screenshot. You can start taking the screenshot from here. Okay. Come on, everyone, quickly start taking the screenshot of the slides. Next page. The next page. The next page. Do take the screenshot. These are your final notes. It will help you in the time of revision. The next page, even the definitions are there. So please do take the screenshot. The next one. Yeah, Prashant, that's what I told. Yeah, I'm going to talk about sensitivity. It's a topic of today's class only. I'll come to that. The next one. So all the definitions are also included. So that's why no running notes required. Just take the screenshots. Yeah, Bunty, it is correct to say that input is operating independent of the measurement of the output. It is correct to say that. Next screenshot, the differences between them. Okay, fine. Chaliye, so I hope you have followed with the screenshot. Save them folder wise, arrange them. That's up to you. Okay. Chaliye. Yeah, Aditya, we'll learn that in the controllers. We'll learn that. I cannot say it in a single line, but I'll explain you step by step mathematically and all. Okay. Yeah, it's correct to say that it gives the controlled output. Me, that's correct to say that. Jyotsna, you will also get the study notes in the PDF from the Grade Up app site, from the Grade Up team. That may be little different from what I'm giving. So that is also an additional tool, but better to follow what you're learning in the class. Okay, because those notes are not designed by me. There's a content team working on that. So keep that also. Okay, but as I told, if you are following my class carefully, so again, no extra notes, no extra book is required. So I just suggest you to take the screenshot. Do not miss. You can have those PDFs, you can download and save, but I think this should be your main focus area. Okay. So again, around around 28, 29 classes I have kept for control system, quite in detail, quite in detail, and that is why very confidently I say no need for any other notes or books. Chaliye. So dear students, before I move forward, I need to have a small review, quick review. Okay, we are not going to involve into the calculations because it is just going to take a lot of time. But we are not here to study signals. We are not here to study Laplace. But basic Laplace formula that you must know. Basic Laplace formula that you must know. What is the Laplace transform first of all? What is the Laplace transform? It is given by integral 0 say infinity xt e power minus st dt. Xt e power minus st dt. Okay. Acha, first of all, let me tell you a fact here. And before I move forward, at least I'll tell you one basic fact here. Just a minute. Yeah, guys. Yeah, Yugandhar, they are actually different, but what I'm trying to say, just listen to that. That's what I'm commenting here so that you are not confused. In the controls, okay, in the theory of control systems, we are only going to talk about causal systems and causal signals. Causal signals and causal systems. And I'll just tell you, if you have not learned control, I'll tell you what is basic required. A causal signal is one such that xt is equal to 0 for t less than 0. Okay. xt equal to 0 for t less than 0. That means, Yugandhar, as you are telling, suppose if I say xt is equal to 1. Okay. Suppose if I say xt equal to 1, it automatically means, it automatically implies, it automatically is equal to 1 for t greater than 0. Okay, we are not going to consider a signal which exists for t less than 0. T less than 0. Okay, that is what causal, what is the concept between causal and non-causal? It's the dependency of output on the present and past values and future values. So I'm not involving yourself into that. Whatever is required, but whatever minimum is required, that is not going to disturb your control system, that is covered. So automatically, if I say xt equal to 1, whenever I say control mein xt is equal to 1, it automatically means xt equal to 1 for t greater than 0, and that is nothing but the unit step signal. That is nothing but your unit step signal. Okay, the unit step signal which looks like this. Okay. Anyways, I'm going to do the step response and ramp response analysis. So there I will take the step and ramp properties whatever required. So ut is equal to constant 1 for t greater than 0. Is equal to 1 for t greater than 0. Correct, everyone? Automatically 1. Okay, so that's what causal signals and systems, and that is why when you study the Laplace transform in signals, if you have learned Laplace in signals, Laplace transforms are actually of two kinds: bilateral Laplace transform, unilateral Laplace transform. Bilateral Laplace transform and unilateral Laplace transform. Bilateral and unilateral. Bilateral has the limit minus infinity to infinity. Unilateral, also known as one-sided. Bilateral known as two-sided. What is one-sided? Matlab where the limits of integration are for 0 say infinity. That means if you are talking about causal signals, anyways. See, if you are talking about a signal which is, anyways a signal which is equal to 0 for t less than 0. Which is equal to 0 for t less than 0. So even if you put this inside the bilateral Laplace transform, the limit can be broken from minus infinity to 0 and 0 say infinity, but the signal does not exist from minus infinity to 0. Which signal? Which we are going to discuss in the control. Which we are discussing in the control. Okay, so what is the only thing that is going to be left? It is 0 say infinity. It is integral 0 say infinity. So that is why we separately define a transform known as the unilateral Laplace transform for the discussion of causal signals. Okay, causal signal. Okay, so unilateral, one-sided. Okay, unilateral means one-sided. Bilateral means double-sided. So this is what is the unilateral Laplace transform formula. Integral 0 say infinity xt e power minus st dt. Right. Now, what is the Laplace transform for e power minus at? This is some calculations, not pretty much. We don't need to derive this. I will be focusing on the derivation of control, but not on Laplace. This is some prerequisite. Okay, but it is a very simple case. I'll just show you one calculation. It is integral 0 say infinity. If the signal is e power minus at, then multiply by e power minus st dt, and this is nothing but equal to integral e power minus of s plus a into t dt from limit 0 say infinity. What it is going to become? You all know the integral of e power ax. So it is e raised to the power minus a plus st divided by minus of a plus s, the limit 0 say infinity, and put down the upper limit minus lower limit. Upper limit is e power minus infinity, which is 0. Lower limit is e power 0 divided by minus of s plus a. What is left? Okay, this is what? This is 0 minus 1 upon s plus a, minus s plus a. Minus minus cancel kariye, you will get the answer as 1 upon s plus a. Okay, so that is how, using this formula or some properties, Laplace transforms are calculated. What I want you to remember, okay, come to the main point. What I want you to remember is the basic Laplace transform fair. So आप क्या करेंगे ना? आप क्या करेंगे? If you are not aware about the Laplace transform, what you are going to do? Okay, this is just, I'm just going to erase this. Just shown you the calculation. Just shown you the calculation. You will enjoy the calculations of Laplace once it is in the signals. Right now, I want the results. So what I want you to expect is, that is after today's class, after the second class. Anyways, you are going to take the screenshot of this. Okay, just if you have not known this formula, just try to fit this formula in your mind. That is what I expect from you. This is the only prerequisite. आप बोलते हैं ना prerequisite. That is what is the prerequisite I expect from you, and that also I am giving you in the form of notes. You don't have to wonder here and there. What are the important formulas I require? E power minus at has the Laplace transform 1 upon s plus a. E power minus at में ही put a equal to 0, so you get e power 0, which is 1. Or the unit step signal. So if you put a equal to 0, what is the Laplace left? 1 by s. Okay. Then using some properties, you get to the Laplace transform of t, which is the ramp signal, 1 upon s square. Laplace transform of t power n, it is factorial n divided by s power n plus 1. Factorial n divided by s power n plus 1. That means if I ask you what is the Laplace transform of t cube, it will be given by 3 factorial divided by s power 4. That means 6 upon s power 4. Okay. 6 upon s power 4. Okay. And Laplace transform of unit impulse signal is 1. Laplace transform of the unit impulse signal is 1. Next, Laplace transform of the important cos and sin omega t. Okay. How can you find the Laplace transform of cos omega t? I'll just hint out. Cos omega t and sin omega t. Cos omega t can be written as e power j omega t plus e power minus j omega t divided by 2. Euler's identity. And then use this formula. Okay, and then use this formula. Which one? E power minus at. Okay. E power j omega t plus e power minus j omega t divided by 2. Okay. E raised to the power j omega t plus e power minus j omega t divided by 2. Yeah, Nihar and Arun, let me see if I'm able to manage an extra time. I'll comment on that, or else you can ask this in the doubt session. Because why, there's also a reason why Laplace transform came up. Why, how the S domain came up. Okay. Why it is important? Why do we go for transformation? So there are some reasons, and I need to take out some time and explain it to you. So if I get the time in the class, I'll tell you. Otherwise, you can ask me in the doubt session. You are a paid student, you have the doubt session, just tag me and I'll reply to it. There I'll tell you, it's better. Okay, so that we don't lose the rhythm of the class. Fine. So after solving this, e power, e power j omega t, e power minus j omega t Laplace, this is what you get. S upon s square plus omega square for sine omega t is omega upon s square plus omega square, e power minus at cos omega t by the s shifting property. There is a s shifting property, and I'll show you that also. Only there are various properties of Laplace transform, but in this control course, I need only 3 or 4 of them. I need only 3 or 4 of them. I don't need much. I don't need much of the properties. So Laplace transform of xt, if it is xs, Laplace transform of xt minus t naught is given by xs into e power minus st naught. If there is a shifting in the time domain, there is an exponential term multiplied in the s domain. There is an exponential term multiplied in the s domain, correct? And then vice versa, if there is an exponential term multiplied in the time domain, e power s naught t into xt, there is s shifting. There is shifting in the s domain. There is a shifting in the s domain, and that is what is done here. Cos omega t Laplace transform, you know. Okay. Then e power minus at cos omega t. If it is e power minus at here, the s is shifted by s plus a. S is shifted by s plus a. So that's what I've done. S plus a upon s plus a whole square plus omega square. Same I've written for e power minus at sine omega t. Okay, this is the only prerequisite. Okay, and few more slides now. So Laplace transform, I'll just mention. Laplace transform is just the prerequisite of that course. And whatever formula you need to remember, I'm just giving you. What you have to do is simple. Take out 5 minutes or 10 minutes of today time. Take down properly in your notebook and save it somewhere. Just go through it once. You will be able to have it in your mind. That is sufficient for control systems course. Okay. Then the derivative property of the Laplace transform. If xt has the Laplace transform xs, then d by dt of xt has the Laplace transform sxs minus x0, where x0 means the initial condition. X0 basically means the initial condition of the signal xt, initial value of the signal xt. Okay. Similarly, second derivative has the Laplace transform s square xs minus s x naught minus x dash naught. Okay. Only one more property I need. I told there are 10 to 12 properties of Laplace, but I am taking only 4. Time shift, s shift, differentiation property, convolution property. Not more than that is going to be used in the control system. Okay, so what is the convolution property of the Laplace transform? This is important. If xt and yt has the Laplace transform xs and ys, then xt convolution yt gives the Laplace transform xs into ys. Matlab, if you take the convolution in the time domain, the Laplace transforms are multiplied. If you take the convolution in the time domain, the Laplace transforms are multiplied. Okay. And guys, now just follow with me. Suppose you have a LTI system. What is LTI? This is basics of the signals course. Linear time invariant. LTI means linear time invariant. LTI is linear time invariant. Okay. And you apply an input RT to the system and you obtain an output CT. Okay. Let us say GT be the impulse response of the system. Now, because I am telling GT as the impulse response, guys, I am telling on the formula level some signal thing. If you need more about this, if you have any queries more about this, just type in the comment box. No, Yugandhar, R is just the name given to the input, R of t. You can take any name, X of t, take any name. R is just the name of the input given. It's not, R does not mean ramp here. Yugandhar, it's the name. R does not mean the ramp signal here. It is just the name given to signal. It can be any signal. What all type of signals? What is important that you will learn? Impulse can be there, step can be there, ramp can be there. So RT is just the name of a signal right now. Okay, guys. So what is impulse response? Impulse response basically means the output of the signal. Okay, the output of the system. Output of the system. Yeah, Zishan, that's why I removed my video. When the input is unit impulse signal. The output of the system when the input is unit impulse signal. Okay, so GT is the impulse response, and this basically, okay, GT is the impulse response that I've written here also, and this is basically a formula to find the output of any LTI system. This is basically the formula to find the output of any LTI system, that is RT convolution GT. Input convolution with the impulse response gives the output of the system. Input convolution with the impulse response gives the output of the system. That is what you study in the LTI systems. That is what convolution is. Okay. And guys, now using the Laplace property, xt convolution yt has the Laplace xs ys. Matlab RT convolution GT has the Laplace transform rs into gs. Rs into gs, and that is equal to cs. That is the Laplace transform of the output. So what is output? Output is equal to output. I can say this in the sense that output is given by the simple formula input multiplied by gain. How do you calculate the output of any system? How do you calculate the output of any system? Input into gain of the system by which the input is amplified or attenuated. Okay, the output is equal to input into gain, and then that gain factor means GS. That gain factor means GS. It can be written as what? This GS can be written as output upon input, the ratio of output upon input. So GS, which is equal to ratio of upon output upon input, is known as the gain, or very commonly known as the transfer function of the system. Okay, very commonly known as the transfer function of the system. The ratio of output Laplace transform to the input Laplace transform is known as the transfer function of the system. The ratio of the output Laplace transform to the input Laplace transform is known as the transfer function of the system. That is what I am giving you the definitions also here. Okay, the transfer function of a system is defined as the ratio of output Laplace transform to the input Laplace transform. Okay, and it is also equal to one more thing. See, in the basic derivation, where has GS come from? Where has GS come from? GS kahan se aaya hai? GS has been substituted as the Laplace transform of GT. Laplace transform of GT. So I can also write this. Yeah, Shubham, in a sense, it is responsible. If you know the gain of a system, if you know this function, GS, then it is responsible for determining the transfer relation between input and output. Matlab, given this transfer function, then you can convert any input into the output. Any input into the output. So basically, relation between how the input is transformed into the output. How the input is transformed into the output, that depends on the transfer function of this system. Okay. Input multiplied by the gain, input multiplied by that transfer function. It is a function which is responsible for the transfer of the input to the output function. So it transfers the input function to the output function. You can say like that, Shubham. Okay, you can say in a very basic term, you can say like that. Okay. Okay. Yes. So what I'm telling that GT is the impulse response, and taking the Laplace transform of GT, I got GS, and that is what I'm writing here. Mathematically, it is also equal to the Laplace transform. It is equal to the Laplace transform of the impulse response of this system. That is what is the formula I've written here. Laplace formula, integral 0 se infinity GT e power minus ST dt. Okay. Now transfer functions are applicable only for initially relaxed systems and SISO systems. Two major limitations of transfer function. Two major limitations of transfer function. It is applicable only for initially relaxed systems, that is zero initial conditions, and applicable only for SISO systems. Now let us take one example, students. Let us take one example. Okay. Determine the transfer function of the system. A simple differential equation has been given. Okay. Shrikant, what about the GT part? Matlab, which part about GT you want to know? It is the output of the system when the input is unit impulse. Okay. Yeah, Akash, we'll give time for screenshot. Just wait on a minute. And I hope you are aware about the unit impulse signal. Okay. Determine the transfer function of the system. D by dt of yt plus 4yt is equal to 3xt. D by dt. If you are not aware about the impulse, just give me a moment. I'll tell you about the impulse signal for all. Okay. Let us complete this question first. Now, guys, use the Laplace transform property. Now, d by dt of yt plus 4yt is equal to 3xt. Okay, 3xt. Okay, now Laplace transform. Apply the Laplace transform. So what is the Laplace transform for d by dt of yt? It is sys minus y0. The actual property of the Laplace transform with the initial condition. It is s into ys minus y0 plus 4ys is equal to 3xs. Is equal to 3xs. Correct. Sys minus y0 plus 4ys is equal to 3xs. Okay. Now I'll take two cases here. Suppose that if y0 is equal to 1. Suppose that if y0 equal to 1, then you get s plus 4 into ys common minus y0, which is 1, equal to 3xs. And transfer function means what? It is the ratio of input to the output. It is the ratio of the input to the output Laplace transform. But will you be able to solve here ys divided by xs? Will you be able to get the ratio? Even if you divide by xs, you will get this term 1 upon xs. This will be left out separately. You will not be, and transfer function should not involve any input or output. Transfer function is a ratio between input and output, but that transfer function should not itself include the input or output. Otherwise, there is no meaning of defining it. So, will you be able to find the transfer function? Okay. Now, cannot be found. It can't be found anyways. How much you are try, kitna bhi try kar lijiye, it is not going to come here. Why? Because you have taken a non-zero initial condition, any non-zero value. Okay, so it is, as I told, it is defined initially only for initially relaxed system. So if I take the second case now, suppose y0 is equal to 0. Okay, then I have s plus 4 multiplied by ys minus y0, which is 1, equal to 3xs. So now you get the answer, guys. Transfer function y of s divided by x of s is 3 is divided by s plus 4. 3 is divided by s plus 4. Okay. 3 divided by s plus 4. That's the transfer function answer. Yeah, Shashankar, that will be the impulse response. If I ask you what is the impulse response, but more or less impulse response will not be of our concern, because mostly the derivations mostly that we are going to take is going to be in the S domain. Okay. But if you want the impulse response, take the inverse Laplace transform, and after taking the inverse Laplace transform, you get 3 e power minus 4t. 3 e power minus 4t into ut. Now, ut written or not written in control system, it is equivalent, Shashanka, because I have told you we are only going to talk about causal. Because 1 upon s plus 4 is the Laplace transform for e power minus 4t. The reverse I have taken, inverse Laplace transform. But mostly this is not going to be what is asked to you. Because all the derivations of time response and everything that you are going to see in the control system stability also, that is in the S domain. So what is important for you is to get the S domain. Clear, everyone? Yes. This is a simple one. I have been able to obtain the transfer function here. Okay. Can we do it for the other question? Only transfer function. I don't want the impulse response. Okay. And those of you, I'll just give you the hint about the unit impulse. Those of you who are not aware. Unit impulse, commonly represented as delta t, and it is defined as delta t equal to 0 for t not equal to 0. Okay, t not equal to 0 and delta t is not equal to 0 for t equal to 0, and that is, it is undefined at this point if I put up the actual value. Okay. Yeah guys, correct answer for the transfer function. Delta t is equal to 0 for t not equal to 0 and delta t equal to infinity for t equal to 0. Okay. That means this has a waveform of this form. I'll just show it to you. This is a unit impulse signal. It is shown with an upgoing arrow. It is shown with an upgoing arrow, which clearly means that at t equal to 0, its value shoots up to infinity. Its value shoots up to infinity, and it has a quantity known as unit area. Okay, it has unit area. This unit impulse signal has unit area. Okay, yes, unit area. That means integral minus infinity to infinity del t dt. Integral minus infinity to infinity del t dt equal to 1. Okay, and how do you just remember the impulse? Listen everyone, impulse means practically impulse, ये तो mathematical model हो गया. Practically impulse means a type of signal which exists for a very short amount of time, ideally zero, but that is just ideally, but a type of signal, okay, type of signal which exists for a very short duration of time, but whose impact, whose magnitude is large. Infinity is just ideal, but whose magnitude is large. Something like this, if you are able to see this. Suppose this is my hand, and if I just clap it with the other hand very quickly, look at this. What is this? What is this activity? Can you define the time of this impact? Can you define the time of this impact? Can you define the time of this impact? Yes, it's almost immeasurable. It's a very, very small immeasurable time. You can't exactly define the measure of this time. It's almost immeasurable. Okay, you can't say for what time I have touched my hand. But within that very small amount of time, the impact, it is large. Impact is large. Okay, in something like this, I just give a hit here. I give a hit here. Okay, or take other examples like a bat hitting a ball, a cricket match, a bat hitting a ball. In a cricket match, a bat hitting a ball. Okay, for how much duration does the bat hit the ball? It's again almost very small, immeasurable almost. The bat hitting the ball. But the impact, the force is large. Relative to the time, the force is large. Okay. Same with the football, your leg, your foot hitting the ball. What is the duration? Can you say it is just touching the ball for maybe 1 second, 2 seconds? No, not at all for 1 second, 2 seconds also. Okay. So the bat hitting the ball, the foot hitting the your football. Okay, exactly, Biram, keep it very simple. Large amount of force on a very short duration, for a very short duration. Yeah, Bunty, this was something like slap only. Okay. Yes, Dhoni stumping. That's good, Girish. Dhoni stumping. That's not applicable for all wicket keepers, but yeah, it can be applied to the Dhoni stumping case, exactly. So some activity, some force which is relatively large in magnitude but exists for a very small amount of time is unit impulse signal. Okay, fine. Come back to the question. That's what about the impulse signal I wanted to tell you. Let's go back to the question and solve this. Determine the transfer function of the system d2y by dt square plus 3dy by dt plus 2yt equal to xt. d2y by dt square plus 3dy by dt plus 2yt equal to xt. Take it in the Laplace domain with zero initial condition. Now you need to know that. Yeah, I don't know, someone was asking me, I just skipped that comment. Someone was asking me that how I know it is relaxed or not. Nothing is given. So even if nothing is given and if the question is on transfer function, yeah, Abhilasha, that's what I'm commenting on. Nothing is given. I don't know whether it is relaxed or not relaxed. But if they're asking the transfer function, you will have to take it as relaxed system, because as I've shown you in the earlier example, for non-zero initial condition, the transfer function cannot be found only. Okay. So if it is a transfer function question, by default, you have to take it as zero initial condition. So see, these are some questions, basic level questions from signals and Laplace transform, but just for the comfort level of Laplace, I'm taking this. Okay, so take it as s square ys. Don't write down the initial condition. Write down directly 3ys plus 2ys equal to xs So now y of s divided by x of s is equal to 1 upon s square plus 3s plus 3sys. No, yeah, 3s plus 2. Yeah, Sarath. Area for impulse is 1. I specified. Na? Area for impulse is 1. Ys upon xs is equal to 1 upon s square plus 3s plus 2. That's the transfer function. You can find the inverse Laplace transform by breaking into partial fraction and all, but not required. Jahan required hoga, I'll tell you. Okay, suppose if that is required, I'll tell you, but right now it is not required. So just the transfer function I've written. Okay, quickly taking one more example with you guys. Quickly taking one more example. d2y by dt square plus 6dy by dt plus 8yt. Matlab s square ys plus 6sys plus 8yt. So plus 8ys is equal to d by dt of xt, matlab x into xs plus 3xs. Okay. Used all the initial conditions as 0. Used all the initial conditions as 0. Okay. So from here, what is the ys divided by xs? What is the ys divided by xs? So on the right hand side, you take xs common and divide on the left hand side. So it is s plus 3 is divided by s square plus 6s plus 8. S square plus 6s plus 8. S plus 3 upon s square plus 6s plus 8. Okay. So that means I can write down the transfer function here. Let's say I write down the transfer function as t of s, which is s plus 3 divided by s square plus 6s plus 8. Here we can also, even in the last case also it was possible. Here I can factorize my denominator. I can factorize my denominator as s plus 3 divided by s plus 4 and 2. So s plus 2, s plus 4, s plus 2, s plus 4. Okay. So this is the factorization. Now guys, what happens in this transfer function? What happens if you put s equal to minus 3? If you put s equal to minus 3. This is something we have discussed in the mathematics also. The small thing we have discussed in mathematics also. Okay. If you put s equal to minus 3, the value of the function becomes 0, and such points are known as zeros of the function. Such points are known as zeros of the function. The value of s, I have the definition, the values of s for which the transfer function becomes 0. Okay. And if you put s equal to minus 2 and minus 4, then such points are known as poles, because s equal to minus 2 and minus 4, what is the form you are getting? You are getting 1 by 0 form. You are getting 1 by 0 form. Either you put minus 2 or minus 4. You are getting the 1 by 0 form, and 1 by 0 tends to infinity. So what is the definition of poles? It is the values of s for which the transfer function becomes undefined. Okay, that is the basic meaning of poles and zeros. Okay, again you study this in signals. I've taught you in mathematics because we had a chapter of complex function. Okay, so that's what I'm just repeating for you here. And that's what is the pole zero diagram. I'll just show you the definitions first. The values of s for which the transfer function becomes 0. The values of s for which the transfer function becomes 0. Okay, are known as the zeros of the function. Okay, and the values of s for which the transfer function becomes undefined. Infinity, are known as the poles of the function. Okay, the values of s for which the transfer function becomes undefined. Okay, and I have the simple pole zero diagram here. This is known as the s plane. I'll write down some more terms. S plane. Okay, where you plot the complex number. S is general. See guys, S is general is what? S in general is a complex variable that you study in the Laplace transform, sigma plus j omega. So this is known as the real axis, where you plot the sigma, real part, and this is known as the imaginary axis, matlab j omega axis. But right now, what are the poles and zeros here? Poles are -2, -4, and zeros are -3. So how do you represent the poles? Poles are represented by the cross marks. Poles are represented by the cross marks, and zeros are represented by a zero symbol, like an oval symbol only. Okay. So -2 and -4, these are the poles, and -3 was the zero, continuing with the same transfer function. -3 was 0. All the poles and zeros are right now real. It may be complex. We will see complex poles and zeros also. It is right now real. That is why lying on the real axis. Real axis matlab the x-axis basically. Okay. The portion of the complex plane before the left half plane, before the imaginary axis, y-axis, now known as the imaginary axis, divide the portion into two halves, the left half and the right half. This is known as LHP. The left half portion, this is known as the left half plane. Left half plane, left half S plane. And this is known as RHP. It is right half plane. It is not RHF. It is wrongly printed there. RHP, the right half plane. And the LHP and RHP are basically repeatedly going to be used once I start the stability. Poles lying in the left half plane or poles lying in the right half plane. Okay. So this is the pole zero plot of the function, and I've defined the poles and zeros for you. Clear about this definition? I've simply defined the poles and zeros for you right now. Just okay. Just define the poles and zeros for you right now. Okay. So now moving forward, I'll give the screenshot just a minute. Let us first of all take the block diagram of the open loop system and the closed loop system. The block diagram of the open loop system and the closed loop system. And dear new student, just keep on patient, just keep with patience. This is my habit. The batch 1 students already know that usually I extend my classes to tell you more about the concepts. So at least मेरे classes के लिए habit डाल दो. I do extend the classes little bit. Take a little bit because I have a lot of content to tell you in this control system also. I have a lots and lots of content, and basically this class extra time is going just because of that Laplace revision. I know signals is not done. अगर आपने signals पढ़ा होता तो I just could have skipped that. I assume that you know, but just to make you familiar की basic calculation, what are the basic Laplace formula and what is basically the transfer function definition. If you have learned the signals course, then that discussion is not at all required. Not at all required, but I have taught you. I thought there should not be any obstacle. That should not be any obstacle. Yeah, you can say, I accept that's my specialty. I accept. Even, you know, in the vision batch, that is till 11:30. My classes even were going up to 11:30 p.m. My classes were going up to 12. Students were very comfortably sitting. Okay. Students were very comfortably sitting even in the night. Right now it's just evening. Right now it's just evening. So आप लोग के पास तो, you know, you have ample amount of time. Okay. Not always, but in the first class only I tell you just keep a habit of that, because, you know, and it's just for your betterment. You know, just wait till the end of the course. At end of the course you will understand कि हमने A to Z means A to Z learn कर लिया है. Okay, so just that's for your betterment. At the end you are going to get benefited. है ना? चलिए. Yeah, maybe in mathematics only one class you completed before time. I remember that was one Sunday class. What topic it was, I don't remember exactly. On one Sunday. Chaliye, let's not deviate from the topic. So open loop system, you know, only has one, you know, open loop system was what? Where the output has no effect on the control system of the input. Output has no effect on the control system of the input, right? And you just have an input applied on a system. This is the transfer function of the system, and you obtain an output. That's what open loop is. Okay. Apply the input, get the output, but the output is not going to affect the input. This value of output is not going to affect the input. That is what open loop is. Yeah, exactly correct. That was the partial differential equation class. Correct. Your good memory, Surya Prakash and Biram. Partial differential equation class. Come back to this class now. The output does not have any effect on the input. Okay, open loop system. So just apply the input, measure the output. So what is the measurement of the output? I've told you now. How do you calculate the output? I'm just representing this open loop system by a block whose gain is GS. How do you calculate the output of any block? Input into gain. This is input and multiplied by the gain. Okay, so output is just measured by applying the input. So what is the only transfer function that is applicable is GS. And already repetition of the transfer function definition. It is CS divided by RS. It is CS divided by RS. But if I take you towards the closed loop, okay, guys, this is not the starting of the block diagram reduction rule. Block diagram reduction is next class, immediately next class. But in the block diagram reduction, we are going to talk about complicated block diagrams to be reduced. I am just giving you the block diagram of the open and closed loop because we have discussed open and closed loop in the today's class. Okay. Okay. So closed loop system anyways has that same heating element. Suppose that the heating elements are defined by the function GS. Okay, so it has the heating elements GS, but it also had the temperature sensor. Remember that electric clothes dryer, same example. Remember that it has a feedback element and the feedback path gain is equal to HS. The feedback path gain is equal to HS. Okay, suppose that the feedback path gain is equal to HS. Now I'm going to define various nodes and various signals. Listen with attention. This is what RS is the input. CS is the output. Okay, and then GS is the forward path transfer function or the forward path gain. What is the forward path? Now, whenever I say forward, matlab path from input to the output. Input to the output. Whenever I say HS, now HS is the feedback path gain, and whenever I use the word feedback is a path from output towards the input, reverse path. This path, the path from the output towards going towards the input side. Right? And let's say HS is the gain involved in the feedback path transfer function or feedback path gain. Then BS is actually the feedback signal which is going to be used with the comparator. I told you that there will be one comparator to correct the input. Okay, comparator to compare the value of what is the current status and what is the expected status of the system. Okay, so this is basically a summing point used to compare and used to take the difference of them, and the signal which is going to the comparator is known as the feedback signal. The output of the feedback path, basically the output of the feedback path is the feedback signal, and this US is known as the actuating signal, the corrected input in a sense. Had there been actuating signal in a sense is the corrected input. Had there been no feedback, GS पे क्या apply हो रहा था? Just look at the previous case. Okay, if suppose there is no feedback, what do you apply on the GS is directly the input RT, na? So what is applied on GS? GS is the main system, but to have the better accuracy on the system, we connected in the feedback form. So in the GS system, in the open loop case, we applied the input as RT. Now, what is the input that is being applied to GS is US in the S domain, and that is known as the actuating signal. So in a sense, you can say that it is the corrected input. Okay, yes, Bram, I'm talking about negative feedback. Okay, so let me just write down the simple equations. Can you write down what is the BS signal? The feedback signal. Can you write down what is the feedback signal? Look at this. The output of any block is equal to it is equal to input into gain. So what is the input of this block? It is coming from CS, and the output is BS. So I can write it as input of this block is CS and output of this block, gain of the block is HS. CS into HS. Okay. Then what is the actuating signal? What is the actuating signal? Look at the summing point. Actuating signal is the difference of RS minus the feedback signal, and that is equal to RS minus C of S into H of S. Okay. Guys, listen, some of the Indian author textbooks, I'll tell you with the precaution first of all, some of the Indian author textbook will call this always as the error signal. Some of the Indian author textbook is going to call this node as the error signal, but this is not correct. Okay, this is not correct. The actuating signal, I'm going to talk about this in the error class. Actuating signal is not equal to the error signal because the error signal is standard defined as the difference between RS and CS. Difference between the reference input and the obtained output. Okay. So, why this error is defined, and there I'll talk more about the steady state error class. I have a class separately on discussing the steady state errors. So there I will discuss about the error. But in some of the books you see they just call it as error. Okay, it will be equal to error if I take HS equal to 1. चलिए HS को 1 कर दीजिए. HS को 1 कर दीजिए, तो you get R minus C. So if it is the unity feedback, then it is equal to error signal, but generally not. Generally not. US is not equal to ES generally. Okay. Chaliye. So let me come back to this calculation. This is what you may see in some of the Indian author books. That is why I have told you. Okay. What is the correct definition of error? I'll tell you in the error class. So now what is the output CS? It is time to find the output CS. Output CS. So output CS is equal to, it is the output of the block whose gain is G, and the input of that block is US. So input into gain, right? Look at this block. Look at this block. Input multiplied by this gain gives the output. So input into gain. So input is US into gain. Right now we have just found the value of US, that is R of S minus what? Minus CS into HS. That is the value of US. It is multiplied by GS. Okay. Multiplied by GS. C of S. Now Aruna, there will not be many US. Actuating signal is one that is applied. Just remember, actuating signal is the one that is seen at the input of the GS block. That is seen at the input of the GS block. Okay. So CS is equal to, yes, let me complete this, RS into GS minus C of S into H of S into G of S. Yeah, Payal, you can ask me if there's anything going fast for you. I think we are going moderately, relatively slower only. No, but not slow also, but we are going moderate. If anything is hurting you, Payal, you can ask me, no issues. Just comment anything fast. CS is equal to RS into GS minus CS HS GS. So take the CS terms on the left hand side. All the CS terms on the left hand side. So you get 1 plus GS into HS. And that is equal to RS into GS. Okay. So what is C by R equal to? Transfer function basically means C by R. Na? What is the transfer function of a system? Transfer function of a system is the ratio of the output Laplace transform to the input Laplace transform, and that is coming up as G of S divided by 1 plus GSHS. Now that is a formula that is going to be used almost everywhere in the control system. Yeah. See, these basic classes are just for basics. Introduction class it is. Direct questions will not come up here, but yeah, although everything you are going to, what you are going to use, I am speaking it. I am speaking about that. Okay. It is GS divided by 1 plus GSHS, the transfer function. GS upon 1 plus GSHS. Okay. Yeah, Shivashankar, that's fine, because I know when the important topics come like Routh-Hurwitz, Nyquist, where we need more patience, I'll keep that. Maine bola na, this section, don't expect any direct question, but we can't skip this also because without the basic formula and basic definition, we can't proceed also. So some topics are like important for understanding, but not important for questions. It is there in every subject, important for the basics, but not important for questions. This is one of that class, introduction class. Okay. Now, open loop, there is no error, na, Shashanka. In open loop system, we are not measuring the output. So, how can we measure the difference between input and output? There is no error node in the open loop case. Okay. GS is divided by 1 plus GSHS. GS is divided by 1 plus GSHS. Yes, Jogeshwar. That's correct. Understood this? This is the transfer function of a closed loop system having forward gain G and feedback gain H. G divided by 1 plus GH. Okay. Now, I'll tell you something about positive and negative feedback system with time. I'll tell you something about positive and negative feedback system with time. But suppose right now, just you can take the formula. If it is positive feedback by chance, if it is positive feedback, then the transfer function. Positive feedback, matlab the summing point has plus 1. Right now, I'll just highlight that. If this is minus, I'll just highlight it here. If this the feedback signal is coming in negative form, so that is known as what? The negative feedback system. Because you are subtracting the feedback signal, so that is a negative feedback system. I'll talk about more about negative and positive feedback system. But right now you can just note down the formula. If it is positive feedback, it is Gs divided by 1 minus Gs into Hs. 1 minus Gs into Hs. Right? 1 minus Gs into Hs. Correct, everyone? 1 minus Gs into Hs. Yeah, Meet, correct. Generally, negative feedback systems are used. Positive, because positive feedback systems have stability issues. I'll speak about that. Let us begin with some systems. Positive feedback systems generally kahan honge agar honge bhi, to that is in the design of amplifiers to generate some specific waveforms. Design of oscillators, sorry. Design of oscillators, not in amplifiers. Positive feedback systems are mostly used in the design of oscillators to generate specific waveforms that you want. Okay, chali guys, now let's take it's a time for screenshot up to this point. It's time for screenshot up to this point. The screenshot from the Laplace review of the Laplace. Yes, Deepa, it's oscillator. Positive feedbacks are mostly in the case of oscillators. Come on. Take the screenshots quickly. I'm giving you time for screenshots now from the Laplace transform. Again, I repeat, only my prerequisite is Laplace, and my only request to you is today after the end of second class, when you get free, just remember all this formula. Just try to remember all this formula. Take the screenshot for Laplace. Okay, then next. Yeah, you can take the screenshot here. Yes, Meet. That's correct. Next screenshot. Only few properties of Laplace transform. I didn't want all the properties. Next one. Yeah, Prashant, not only one GATE 2020 question. There are many questions on two-sided Laplace transform that you study in signals. I am not teaching you Laplace. No, Prashant, you will study in signals. Just wait for that. In the signals and systems, you will study both one-sided and two-sided. Yes, Joshna, that's what actuating signal, the final signal, the corrected input that is applied to GS. The corrected input that is applied to GS. Next screenshot. Take the next screenshot. Yeah, Yashwant, the RS will enter the GS block if it is the open loop case. Okay. So suppose, yeah, maybe you designed the open loop system, but you are worried about accuracy. Suppose if you first start designing an open loop system, okay, then RS will enter the GS. This screenshot. But suppose you find accuracy, you want, you want to improve the noise handling of the system. So you now make the system as closed loop system. Okay, you now make the system as closed loop system. And once you make the closed loop system, what is the signal that enters the GS now is the actuating signal, the corrected signal. Next screenshot. Next one. Just take the screenshots quickly. These are your final notes. Even the question and solution I'm giving for screenshot so that everything will be available for your revision, right? Everything will be available for your revision. That is why I'm giving the questions and solutions also. Last में आपको क्या करना है? Just have to revise. Just turn up the notes and revise. That is sufficient. Next screenshot. Pole zero diagram for that transfer function which we just found. Next one, poles and zeros definition. Open loop system, just the open loop system transfer function. Next, closed loop. These are all the terminology with respect to closed loop: forward path gain, feedback signal, actuating signal, error signal I will define later on. Okay, input, output, all the terminology, and then the calculations of that feedback system to calculate the final transfer function. Next one. Yes. And solving that, we finally get the overall transfer function. Finally get the overall transfer function that is available on the screen. G divided by 1 plus GH. Negative feedback system. Negative feedback closed loop system. Okay. Negative feedback closed loop system. Right? Yeah, standard. You can say Yashwant, it's standard. Yes, guys. So, because of the Laplace revision, once again, I repeat that just my only thing I expect from you is just to revise whatever I've told in Laplace once after the ending, today's end, second class end. Okay. So just because of the Laplace revision, we are yet to discuss with the sensitivity, and it's 4:30. So let us shift the sensitivity topic to the next class. No issues on that. And the next class, because yeah, I understand Sunil and Meet, you are very excited. I know mostly will be excited, but let's look into the general cause and effect. So many will be looking for break also, because I know you have attended the class 10 a.m. also. Analog circuits ka bhi class tha aaj. Okay, so let me also have little humanity also with the motivation of teaching. So I'll shift this to the next class. Okay, I'll shift this to the next class, sensitivity, because anyway sensitivity will not be finished in 5-10 minutes. Okay, and then I have to start the next class on time. So ऐसा होगा कि break 0 हो जाएगा. It will be the case that break 0. Okay. Yes, that's what. For the sake of Laplace, I will place the sensitivity in the next class. So next class I will start with the sensitivity and then move towards the BDR, block diagram reduction rules. Okay, block diagram reduction rules. Yeah, Arun Krishna, it is going to be more super in the upcoming days. This is just basic. We will enjoy when once important topic comes, वहाँ बहुत मजा आएगा. ठीक है. So guys, have your refreshment, have your snacks, refresh yourself, because I know break is important, and if I start sensitivity, it is almost going to be 5 p.m. then. So you'll not get the break then. Sensitivity with respect to gate is less important, but with respect to ES, it is more important. Okay. That's what I'll tell you honestly. So I'll start sensitivity straight at 5 p.m. Straight at 5 p.m. next class. Okay. Straight at 5 p.m. next class. See you at 5 p.m. very soon. It's almost 32 minutes left. It's 4:28. And then we are starting with the important block diagram reduction rules. The BDR rules. So next class is about BDR, but we'll complete sensitivity and questions on that. Okay. Chaliye, bye bye and see you on the next class quickly. I'm signing off, otherwise the time will elapse. Bye bye and see you at 5 p.m. Do give the feedback to the session, guys. Do give the feedback to the session.